दासपते सर तुम्हाला होस्ट केलंय?
ओके, ओके. मी करतो आता स्क्रीन शेअरिंग.
ओके. मी एक्झिट करते आता.
या.
हं.
Madam, to topic, madam.
पाटील सर? पाटील सर?
हां, हॅलो.
हॅलो पाटील सर?
हां, नमस्कार.
नमस्कार. अरे काय तुम्ही कसं काय जॉइन केलं? हे गुरु कसं काय जॉइन झालेत माझ्या ह्याच्यात? मला विद्यार्थी हवेत.
कधी-कधी गुरुला सुद्धा विद्यार्थी व्हायला लागतं. त्याशिवाय ज्ञान मिळत नाहीये.
अरे जो ज्ञानी ऑलरेडी आहे त्याने ज्ञान घेण्याची काही गरज नाही.
नाही, नाही, नाही. तसं काही नाही. ज्ञानी आहेच तो. पण तरी काय झालंय, की थोडकंच ज्ञान राहिलंय. जरा ते ओव्हरऑलने अभाव जायला पाहिजे पहिली गोष्ट. आणि थोडं एक्सपेरिमेंट काय प्रॅक्टिकल एक्सपोजर पण मिळायला पाहिजे ना.
अच्छा, म्हणजे तुम्ही या एक्झामला बसलेले आहात का?
नाही, हां, बसलेलं मी यावेळी देतोय पहिल्यांदा.
अरे वाह! 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 म्हणजे तुम्हाला शिकवायचं म्हणजे मला फारच ऑकवर्ड होणार आहे.
नाही, नाही. तसं काय तसं काय मानायची गरज नाहीये. कारण
कारण तुम्ही पण मेकॅनिकलच आहात म्हणजे तुम्हाला यातलं काही नाविन्य नाहीये. एक वेळ इलेक्ट्रिकल असलं तर ठीक आहे, हरकत नाही.
नाही
नो
तेवढं
प्रॉब्लेम.
कसं होईल? काय झालं माहिती आहे सर, एनर्जी ऑडिट अँड मॅनेजमेंट मी 2016-17 पर्यंत घेत होतो.
अच्छा.
आणि त्यानंतर मी गेलो तर थर्मोडायनामिक्सलाच गेलो डायरेक्ट खाली.
हं, हं, हं.
आणि मग मला
बरोबर.
थोडंसं टच
रिफ्रेश
केला.
करायला पाहिजे. बरोबर.
रिफ्रेश करावं लागेल. सगळं रिफ्रेश करावं लागेल. आणि शिवाय प्रॅक्टिकल अप्रोच म्हणा किंवा न्यूमेरिकल्स जरा
बरोबर.
बघावं लागतील. जास्त वेळ द्यावा लागेल.
हां.
तो जरासा हेडेक आहे.
समवते थर्मोडायनामिक्सच आहे, पण तरी हरकत नाही. गुड.
नाही पण परत हे करावंच लागेल ना
हो,
सर.
हो. हो, ऑब्व्हियसली, ऑब्व्हियसली.
गॅप मोठा पडलाय त्याच्यात. जवळ-जवळ एक
गॅप
8-9
मोठा झाला.
वर्षाचा गॅप पडला.
राइट, राइट.
त्यामुळं जरासं वेळ देऊन करावं लागणार
येस,
आहे त्याला.
येस, येस. आपण 14-15 ला भेटलो होतो कॉलेजला म्हणून मी
हो सर,
बिनधास्त
हो सर.
बोललो.
तुम्ही ज्यावेळी नाव आलं ना तुमचं, त्याच वेळी लक्षात आलं, की आपण भेटलो होतो.
राइट, राइट. येस, येस. सिंहगडलाच आहात ना तुम्ही अजून?
अजूनही तिथंच आहे. अजून तिथंच
गुड,
आहे.
गुड, गुड. चल. इलेक्ट्रिकलला धामणे आहेत ना एक?
हां, धामणे सर आहेत की. आहेत.
ओके, ओके, ओके. हां. ते रिलेशनमध्ये येतात थोडे.
ओके, ओके.
Today, which topic, sir? Which topic?
Yeah. Today we are going to cover first topic from paper 2, that is fuels and combustion. Actually, in fact speaking, this topic 2, paper 2 topic 1 is a basic topic for all the topics ahead. This
Okay.
does not cover any practical as such, rather process like heating, cooling, and so on. It covers the basic idea about fuels. Okay.
Okay. Okay.
Now we have 3 participants who have joined.
Okay. Okay.
I'm actually expecting 10 participants as such. I think we'll start or what? Please advise me.
We can start, sir. Is it a recording session, no? Everyone can go through the recording session, sir.
Yeah. So I think we will ultimately start and see how people join and depends on all these things. But we'll start. Okay. I'll now share the screen. Screen is visible or not? Okay.
Visible.
Yes, yes,
Visible.
sir. Visible, visible.
Visible.
Okay, so we will now start. This is paper 2, topic 1, which I just now discussed with you all. So we'll now discuss about various types of fuels in this topic. First, we will cover the liquid fuels. Liquid fuels are given first preference in the syllabus. The reason behind this is that the fossil fuels, which are creating huge emission to the environment, are equally important, still being used by all of us. So ultimately, and one important coincidence is that all liquid fuels have got approximately 10,000 kilocalorie per kg as calorific value, uh, somewhere around 10,000. So we'll learn all these things one by one. Now we go to the properties that liquid fuels have, or actually the properties which we must know for liquid fuels. Basically, this is all very simple. Density is well known to all of us, being engineering, uh, having engineering profile. So ultimately, density is the ratio of mass of liquid fuel in kg to the volume of liquid fuel in meter cube. So it is kg per meter cube, and density is expressed in kg per meter cube. And sometimes we all get confused with specific gravity. Specific gravity is nothing but density itself, but it is compared with a standard uh, liquid which we always prefer as water. So water has got density 1000 kg per meter cube, and all other fluids have got density with reference to that. Automatically, see, petrol has got somewhere around 730, 740 or something. And so comparing with each and every fluid, uh, actually the ratio of density of given fluid divided by density of water is nothing but specific gravity. So density of liquid fuel when compared with density of water, it is called specific gravity. Both numerator and denominator have same units, and that is why there is no unit to the specific gravity. So I already told you about some figures like LDO has got specific gravity 0.85 to 0.87. This clearly indicates that LDO density is 870 kg per meter cube, and so on for furnace oil and for LSHS fuels. So this is what is about the basic properties of liquid fuel. Then next property is viscosity. It is a measure of resistance, internal resistance to flow. It decides pumping ability of fluids. It is also important. Viscosity is more important for use of various oils and storage both. The unit of viscosity is well known to all of us. Centistrokes or strokes. Centistrokes rather is a CGS unit. Strokes is MKS unit. Now, flash point is the lowest point at which fuel can be heated, so that the vapor formed gives off the flashes when the open flame is passed over it. This flash point concept is related to catching of fire. Actually, uh, when the flashes are given up, uh, rather flashes are given up, that time if any spark comes into contact with any other uh, explosive fluid, automatically the fire chances of fire increase. That is why this becomes a limitation on storage of various liquid fuels. And here the one example is given: flash point of liquid fuel furnace oil is 66 degree. So this is the limitation on storage of furnace oil, that if it is stored in tank or somewhere, they or any vessel, the temperature should not never exceed 66 degree. Otherwise, chances of explosion are always there. Same thing. That is what the importance of flash point. Now we talk of pour point. Pour point is the lowest temperature at which fuel will start to flow. That is, hello, hello. Yes, please unmute, or if you want to talk immediately. Hello. Okay, continue. Yes. So flash point of the furnace oil is 66 degrees centigrade. Then we talk of pour point. The lowest temperature at which fuel will start to flow is called pour point. That is, this is particularly applicable even again for furnace oil, because furnace oil is the lowest distillation stage of petroleum distillation. It is at the last stage, and that is why it is not perfectly in liquid phase. It is mixed with solid and all. So it becomes difficult. Flowability in case of furnace oil becomes slightly difficult. So there is a lowest temperature at which it will start flowing. This particular difficulty is observed in industry during the rainy season. Sorry, I am extremely sorry, during the winter. In winter, when the atmospheric temperature is say less than 15, 12, 13 degree, like in that case, the furnace oil does not flow on its own, and there are heaters are placed at the bottom of the FO tank so that it can flow and pumping can be started. So that is what is power point. So this is the importance of power point, that uh, whenever you want to pump a given fluid, it should be able to flow, and that particular point is called a power point. Next is specific heat. It is the amount of, basically for all mechanical rather participants and all, specific heat is very simple concept. The amount of heat required to raise the temperature of fluid 1 kg in mass by 1 degree centigrade temperature. So I already told uh, just a few minutes back that all liquid fuels have got gross calorific value in the range of 10,000, and this is what is mentioned over here. One more practical point I would like to add on this instance is that MTOE calculation, actually it is a part included in paper 1, MTOE calculation. The full form of MTOE is metric ton of oil equivalent. So ultimately this MTOE calculation is done on the basis of this gross calorific value, and the essence or the beauty of calculating MTOE is that various sources of energy, like all fuels and even electricity, everything is a energy. So all sources of energy are converted into oil equivalent. That is why it is called as MTOE. So actually, in first paper you will learn about designated consumers. uh, as example, I will just introduce textile consumer as a designated consumer. But here in Mumbai, if you think of Bhiwandi and all, there are many weaving mills, one after the other, in a uh, given lane, more than say 10, 20, 30, whatever. So all are not designated consumers. So there is a definition for designated consumers, and for all textile industries, if their emission, if their MTOE exceeds, say a threshold value of 3000 MTOE and so, then only they are covered under designated consumer category. And as a result of that, in entire Maharashtra state, there are not more than 6 to 7 textile industries as designated consumer. Uh, in Mumbai, it is Bombay Dyeing and Century Rayon, because their MTOE consumption is exceeding the threshold value, and that MTOE consumption is calculated on the basis of uh, 10,000 kilocalorie per kg as a calorific value for 1 kg of fuel. And all different sources of energy are converted into uh, oil. based on the calorific value. So this is the importance of calorific value and MTOE calculation and relevance with furnace oil or liquid fuels with all other sources of energy. So this is what I wanted to correlate. And this will probably make your understanding of MTOE more easy. I hope so. Okay. So now we go to the fuel properties. Again, actually, fuel content is a major issue. Sulfur content is most undesirable content in fuel. Uh, the reason is very clear to all of us that if sulfur content is there in a given fuel, sulfur will get oxidized due to combustion and will form SO2. And that SO2, when comes into contact with moisture or water, in that case, SO2 will react with H2O and that will form sulfuric acid. And that sulfuric acid will get deposited on the uh, surfaces of the chimney pipe or whatever it is. So all surfaces will get corroded and ultimately the chimney metal will get corroded or any other metal where the it gets in contact will get corroded. So there's a fear of corrosion when sulfur comes into picture in fuels. So ultimately this is causing huge corrosion for the industry and as well as emission also. SOx emission it results into. So ultimately here the sulfur content of all these fuels is mentioned and you will come to know that furnace oil is most rather uh, prone to the problem of sulfuric acid formation and the use of furnace oil has to be avoided. That is why many industries nowadays are switching over to various agro-waste fuels and are replacing the furnace oil or LDO fuel by agro-waste. The reason is clear because of sulfur content and again environment clearance problems like emissions because CO2 emission is also large in this case. In case of agro waste, CO2 emission is minimum. That is why here all these properties which we just now discussed are mentioned in this chart for furnace oil, LSHS and LDO. Here LSHS is mostly the combination of FO and LDO. Okay. So you can observe density of furnace oil is 0.89 to 0.95 and LSHS is also of the same range and LDO actually it is expressed in gram per cc. If it is in kg per meter cube it will be 1000 times more. For LDO it is 0.85 to 0.87. So flash point for these fuels already 66 was mentioned. LSHS is much higher. LDO it is same. Then power point at which it will start flowing is a serious problem for furnace oil as well as for LDO. That is why at the base of the tank heaters are required particularly for winter. And LSHS has got advantage that the power point is 72 degrees centigrade. So ultimately, rather this is a serious disadvantage, I will say, because it will not start flowing or till 72 degrees centigrade. So it has to be kept in hot condition always. Then gross calorific value is this much, which is very close to 10,000, you can say. And in terms of kilocalorie per kg, sediment percent is this, sulfur percent is this. So furnace oil is more prone to acid formation and more quantity of acid will be formed and more corrosion will occur. Water content is this. Water content also brings lot of limitation on combustion efficiency and so on because you have to supply additional energy for converting hydrogen from water into moisture into oxidation of moisture. So ultimately, water content is also a problem. That is why LDO is preferred in many cases. But in general, nowadays, none of these fuel are preferred in market because of many limitations of CO2 emission as well as SO2 emission and so on. With this, we have rather tried to cover properties of liquid fuels, and now we'll move to solid fuels. Before I go to solid fuels, please let me know if any change is required. You are comfortable with my pronunciation, English, and so on, and everything. If everything is okay, then only we'll go ahead. If you want some change, please let me know.
Sir, which oils are being used, sir, now?
What?
Oils. Which oils are being used now in the present scenario?
Present scenario, as such, all the three oils are being used, but all are having the problem with pollution MPCB because of the formation of as rather self acids, and second thing, the limitation is also because of the uh, suspended solids. The total suspended solids in this case becomes higher if you use these fuels in boiler or thermic predators. So ultimately, Pollution Control Board is trying to put limitation on the use of all these three fuels, and gradually these fuels will be use will come down. Okay, so we move to solid fuels.
Yes, sir.
Uh, Now, in solid fuels, basically coal is most important, or coal is widely used. Another solid fuel that is being widely used in India is agro waste, but agro waste has got seasonal limitation. Certain agro waste fuels are not available in rainy season specifically. Moisture content is more. You have to maintain the dryness of those fuels. Otherwise, your fuel consumption will increase and so on. And ensuring availability is a major challenge for all these agro wastes. So ultimately, uh, they keep on changing the sort of agro waste. Instead of using, say, bagasse of sugar cane, they may go for soya husk or coconut husk or something else. But if the routine is formed of using agro waste alternately, actually agro waste will form a very nice future for India, and it is possible that we will become a power rich country with proper ethics and all. So that is again important one, because many farmers are taking undue advantage of this and trying to mix various things in the agro waste. Uh, so now we come to coal. The preparation of coal, there are steps. First, it is sized, then it is conditioned and blended. Particularly, conditioning is done by water, sometimes spraying water and all. Sizing is done by coal mills, and blending is also called as pulverizing. Pulverizing means the fuel is converted into small particles, and this pulverizing results into uh, similar combustion to gaseous combustion. So that is the benefit of pulverization, and this pulverization is a very very important word for thermal power plants, and even coal mills are also widely used in all thermal power plants. So these are the three steps of preparation, and I will say there are two types of analysis for coal: proximate analysis and ultimate analysis, which we should know the difference. Proximate analysis is analysis in which only moisture, volatile content, and ash, all such rather suspended things uh, are taken into consideration, and in ultimate analysis all the uh, periodic chart metals like carbon, hydrogen, nitrogen, sulfur, oxygen, and mineral matter all are considered in ultimate analysis. So ultimate analysis is normally a laboratory analysis, and in power plant lab itself the ultimate analysis is normally done, but proximate analysis is done outside the plant, and in a local environmental lab where all the facilities for measuring percent volatile matter, percent ash, percent moisture, and fixed carbon are provided. So that is called as proximate analysis. In general, there is a practice that ultimate analysis is done on daily basis and proximate analysis is done once in a quarter. So 4 times in a year. So like this, the ultimate and proximate analysis play important role. Here are the figures. Basically, for us, the carbon percent plays very important role in all in various types of coals. You will see that the Indonesian coal has got highest carbon percent. Okay, and that is the reason many industries are other than, I'll say, thermal power plants are using Indonesian coal, because government thermal power plants have to compulsory use coal from coal mines of our country, and they get it in a cheaper rate, and they are located close to the mines. There are many other things like that, but still many other industries using boiler other than, say, thermal power plant are preferably using Indonesian coal because of this fact, that is their fixed carbon percent is much higher. In India, we go for bituminous coal where the carbon percent is less. That is, bituminous coal is this, lignite is this. Basically, not basically because of this carbon percent, this ash percent is minimum. The ash formation is minimum, and again combustion efficiency goes high. Okay, otherwise disposal of ash also becomes a very serious problem. Okay, so as compared to this imported coal, lignite, you will see that lignite is also the best fuel, but again here moisture percentage is a serious issue. I have come across one lignite based plant in Gujarat at some place I don't now remember. Okay, so ultimately there few industries are using specific coal. Okay, which is available in that region, like. So this is about proximate analysis, and then again ultimate analysis, same thing. Uh, the moisture percent is higher here, but moisture percent becomes a serious problem specifically in rainy season. Otherwise, if you are able to store for the coal for rainy season of that is for 4 months, in that case, that coal in that case the running of boiler is very smooth. Then other things, you will see that carbon percent is very high in Indonesian coal. Okay, that is why combustion efficiency is much higher. Okay.
Sir, volatile matter means what, sir?
Volatile matter we have actually covered in the next slides, but I will initially tell you that volatile matter refers to the gaseous content in the given fuel. That is gas-like content, you can say. That is, they say that in solid and liquid fuels, we spend much of the energy in converting that particular fuel into gaseous form. But if there is a volatile content in the fuel, then it is ready to burn or ready to get combusted. So ultimately, if volatile matter is there, the combustion process becomes smooth because it is already converted to gaseous forms. Okay.
Oh, okay.
Now we think of significance of proximate analysis, which we have just now discussed. Fixed carbon, volatile matter, which we just now discussed. Index of gaseous content present in the liquid fuel or even solid fuel, which results into ease of combustion. Okay, now it will be more clear, right? Now for fixed carbon, it is the solid fuel left in the furnace after volatile matter is distilled off. So if volatile matter is deducted, then remaining carbon is a fixed carbon. And ash content, already we know about it. Moisture content and sulfur content. Sulfur content is a major problem in any of the fuel because of possibility of formation of sulfuric acid. Okay.
Sir, sulfur is a volatile matter, sir. Sulfur content.
I don't think so. Sulfur is not present in gaseous form, or it is gaseous. I don't think so. I have to give a thought. Sulfur is not a gas. No? Sulfur, when reacts with oxygen, it becomes SO2, and SO2 is in gaseous form, I believe. Isn't it?
Yes. No, it is.
Now,
It is in the ash, sir. Ash, sir. No.
ash,
Moist.
ash is again unburnt coal and so on. And okay.
Unburned. Okay. In the list, it is not given, sir. Moisture, ash, volatile, fixed carbon only is given.
What is not given?
Sulfur content. Sulfur.
Sulfur content, here it is given na, in my list.
Yes, sir, in my list. Okay.
In the book, I have referred all these things from book only. So I think book also might be giving the same thing. Okay.
Okay.
Okay. Now we go to
Okay, sir.
properties of gaseous fields. That is, we have covered liquid and solids. Now we go to gaseous fields. Actually, in the book, very detailed things are given for, and I have tried to condense it. Only important things I have tried to cover. Okay. Now we talk of properties of gaseous fuels. In gaseous fuels, commonly used are LPG, CNG, and so on. Natural gas is nothing but CNG, producer gas, blast furnace gas, coke oven gas. The calorific value of gaseous fuel is not expressed in terms of kilocalorie per kg as usual. It is expressed in terms of kilocalorie per nm cube. Even in CNG petrol pumps also, they say that it is meter cube. Okay.
Okay.
At normal temperature and pressure. So gases are expressed in terms of kilocalorie per nm cube. Now we compare chemical composition of various fuels like carbon, hydrogen, sulfur, oxygen. It is same thing like ultimate analysis of liquid fuels, to remind you. And here you will find that the coal content in case of gaseous fuels, carbon content in case of gaseous fuels is much higher. It is a comparison between all the three. I am extremely sorry. It is a comparison between the liquid, solid, and gaseous fuels. So at a time you will be able to compare all the three types. In coal, it is approximately 42% carbon content. In furnace oil, it is 84%, and in natural gas, it is 74%. So more the carbon content, you get more combustion efficiency, obviously. And in hydrogen, in coal it is less, and in furnace oil it is 12%, and in natural gas it is 25%. For combustion, we need both the elements, hydrogen and carbon, in a given fuel. Again, sulfur, lesser is better. In natural gas, it is about 0. So ultimately, CNG is much preferred nowadays. The most used fuel nowadays in industry is CNG, but it has got limitations. The supply has to come from government and so on. But coal has got sulfur much less, 0.4%, and furnace oil has got much higher. LDO also has got same, 3 to 4%. Oxygen percent is 1, 9.89, and in natural gas a trace is found. Uh, and all other things are explained to you. As such, ash content is much serious in case of coal. Okay. Specifically speaking, this slide I found very useful for better understanding of combustion process. The three T's of combustions are well known to all mechanical engineers and all. The three T's of combustion are temperature, turbulence, and time required for complete combustion. So time, temperature, and turbulence. Turbulence means the mixture formation, time taken for the intimate mixing of the fuel and air or fuel and oxygen. So ultimately, combustion or burning process happens only when fuel and air come together. So that and they get mixed in each other. So that turbulence phase is very important. Particularly, I would like to remind, not for mechanical again, for all others, not having exposure to mechanical. Actually, actually, uh, carburetor is a concept very well known in petrol engines, and the carburetor performs the function of intimate mixing of petrol and oxygen, and then that is petrol gets converted to gaseous phase and gets mixed with oxygen in air, and then only combustion takes place in petrol engines. That is why carburetor forms very important important part of every petrol engine. uh, so that is what is turbulence in case of turbulence forms important part in case of combustion. And this analysis of sudden fire in all different locations is done with the help of all these three things, three T's of combustion. So ultimately, temperature, turbulence, and time required, time sufficient for the complete combustion plays very important role in combustion process. Now here, these three figures are very important for understanding of combustion as a concept. When we say that the combustion is perfect, you will find that through the flame going out, there will be no oxygen. Only CO2, H2, and nitrogen will go out from the flame, or from the chimney, you can say rather. So better. So fuel and air are mixed together, combustion has occurred, and only these three elements have come into picture after the combustion in the exhaust area, you can say. So this is what is uh, perfect combustion. But in good combustion, O2 will go out, and we normally majority of the combustion process we come across are good combustion, where certain amount of excess air is provided. So ultimately, this heat area, this good combustion is a general or observed in more than 90% cases. This good combustion is observed. This O2, CO2, N2, H2 are the resultant elements at the exit end or exhaust end. So this is good combustion. But incomplete combustion creates a lot of problem, and this incomplete combustion generates CO. So nascent oxygen reacting with carbon of the fuel results into CO formation, and that CO formation results into smoke. All these elements are already there necessarily, CO2 into H2 like that. But this CO formation results into incomplete combustion, and this CO formation occurs only and only when the fuel has got fuel quality is not proper. Rather, if the again practical example, you can say if kerosene is burnt, the CO formation is much higher in two wheelers, I will say. Okay, so ultimately, objectionable smokes do come out in case of when CO formation occurs, and that is what is incomplete combustion. Most of the fuel does not get burned, particularly in case of coal also. If the coal is of bad quality, CO emission takes place, and we find black smoke coming out of the chimney in many of the plants where the boiler is there. So if the fuel quality is not proper, CO emission is bound to occur, and that is what is incomplete combustion, and that results into uh, lesser combustion efficiency in many cases. So this is one part, but this another part is also important. Excess combustion, excess air supplied for combustion plays very important role. Particularly, the domestic example is for agarbatti. I will say, when we rather burn it or light it, in that case we put our hand to control the excess air, and that is what is the excess air in limited form has to be supplied to the combustion, and that is what it results into good combustion. So ultimately, minimum amount of excess air has to be supplied in combustion, and that is what is called as excess air. And this excess air concept has to be learned in next topics by us. Okay, and this is perfect combustion. This rarely happens in some cases where O2 is not there as a result of combustion. Okay, so these are the three T's of combustion: temperature, turbulence, and time. Okay, so should we
Yeah.
go ahead?
So one question.
Yeah, yeah.
How this third T can be controlled or ensured? Time sufficient of complete combustion. How that can be controlled or ensured?
That can be not controlled. I believe. I think so. But
Okay.
if you, in case of fire urgency and all that, we have to be specific, and we have to see that all these three do not come together. That is what is important. Okay.
Okay. Okay.
That is why I have mentioned facts to remember. Oxygen is most important element in every combustion, and in many cases here, oxygen required for combustion is calculated by us in this paper too. And whenever they ask for oxygen percent, or we calculate it, we should take care that oxygen present should always be less than 21%, because as a whole, air contains 21% oxygen, and out of which we take out some oxygen. So ultimately, considering the basic logic of oxygen, our oxygen used for combustion should always be less than 21%, and limited oxygen has to be supplied. So particularly thermal power plants, where I, for energy audit, I go sometimes, I see that their oxygen content in the flue gas is around 3.5 to 4%. They don't allow to exceed it more than 4, because more the excess air, more is the inefficient combustion. Though it is a good combustion, but it is inefficient combustion. So in order to get maximum combustion efficiency, even in coal fired thermal power plants and all, it is preferred that the O2 percent is somewhere near 3.5 to 4. Okay. So fuel needs to be heated only in case of solid or liquids for change of phase. This is what already I have tried to explain in case of gaseous fuels. If the fuel is in gaseous forms, the heat required for conversion of phase is reduced or is minimum, because already fuel is in the form of gas. So the first target in use of any given fuel is that we have to convert it into gaseous form. That is why in case of coal we go for pulverizing. In in case of petrol we go for carburation. So the reasons are simple. Everywhere the fuel, whatever it is, in whatever form it is, we have to convert preferably into gaseous form for the ease of combustion, and that is what is called as volatile matter in a given fuel. So volatile matter in gaseous fuel is on a very large scale, or up to around 80-90% or even more. So that is what is volatile matter. And in solid fuels and liquid fuels, we lose lot of heat energy for converting solid fuel to gas and liquid fuel to gas. Okay. Now we talk of nitrogen. Nitrogen is 79%. Is that is what air, total quantity of air minus quantity of oxygen equal to quantity of nitrogen. And other few elements are there in air, which we have neglected for the time being, but their sum total is less than 2%. Okay, so in for accuracy, you can see that nitrogen is 77%. So the main challenge in combustion process for efficiency improvement lies in proper amount of excess air to avoid the formation of CO, which we are discussing continuously. That we have to limit the excess air, and that can be done particularly in case of boiler with the help of flue gas analysis. And many power plants and many industries using boiler are trying to monitor combustion efficiency and trying to monitor the content of oxygen in the flue gas to get more and more efficiency out of the given fuel. Next is to reduce CO formation. We have to have unburned carbon in the fuel should be minimum or zero. Okay, so minimum unburnt, minimum ash results into more efficiency. Okay.
Sir, this incomplete combustion is there, no, sir.
Right.
In the
Yeah.
N2H2O will not come, sir. Only CO will come, sir. How it is, sir?
Exactly.
Incomplete.
Only CO will come into picture, right? Okay. Now we go to stoichiometric combustion. This word stoichiometric combustion is really a tricky word. People feel very take it very differently, but this stoichiometric word they have found out as such because of the exact requirement of or exact content of fuel, that is a precise amount of carbon and hydrogen in a given fuel to get efficient combustion, and that is nothing but stoichiometric combustion for given fuel. So in simple words, the amount of air required for complete combustion of fuel depends on the fuel content, that is carbon, hydrogen, nitrogen and sulfur in fossil fuels. Thus pollutants are normally expressed as COX, NOx, SOx. If there is a carbon content, it results into COX formation, for nitrogen NOx, for sulfur SOx. The precise amount of air required for combustion is called as stoichiometric air. For this reason, heat balance sheet of boiler or furnace shows maximum loss of heat in dry flue gases. Maximum amount of heat is lost in dry flue gases because of this COX, NOx and SOx formation which are mentioned above. Hence, amount of exact air supplied and content of fuel, exact amount of air and content of fuel in order to result into perfect combustion is called a stoichiometric combination of air, fuel and stoichiometric combustion. Okay, so what plays important role is amount of air supplied and content of fuel. Okay, proper content of fuel for easy for ease of combustion, exact word. Okay, any doubt? We have to solve few problems related to this. uh, I'll say that my focus is more on numericals because it is a very
Sir, this
troubleful part.
sir,
Yes.
sir, one
Yeah.
doubt, sir.
Yeah.
These equations are there, sir. C plus O2, CO2, etc.
Yeah.
Can you kindly express where electrical people actually? C plus O2, CO2, these kgs of carbon has come, sir.
You are
808.
referring to book just now, na?
Yes, sir. Yes, sir.
That is what I am coming to. In the next slide, this is what is there. Okay.
Okay.
Is it right? So we are covering that part immediately. And I have tried to skip rather theory part, much of the maximum theory part which you can read and understand is not covered by me, and I have tried to cover maximum numerical part to get the correct understanding. And I'm sure if you understand numericals you can even write the answer to theory questions also. There is no separate thing because numericals make your understanding very clear. uh, Patil sir with us is expert for all this, knowing all this. And so ultimately the focus in all such cases should be more on numericals. And that is why I have preferred to take this topic because numericals is a good thing for clear understanding also. So we'll focus on this specific numericals, particularly I will say this numerical is already solved in the book, but we'll try to understand it more clearly with the help of this presentation now today. So here the problem is numerical problem is taken for the calculation of theoretical error required. Okay, so how to calculate theoretical error, that we will understand. Uh, Here the content of fuel uh, per, like furnace oil from laboratory analysis are given to us. That is, carbon content in furnace oil is this much, hydrogen is this much, oxygen is this much, and so on and so forth. Based on this content, we have to find out the amount of theoretical air required for combustion, and uh, this will decide the air to fuel ratio for the furnace oil. See, the most funny part or the most interesting part, you can say, is that the answer to these questions are known to us before solving these problems. How? The as you proceed further for studies, you will understand that the standard air to fuel ratio for furnace oil is 14. And before solving entire problem, I can tell you that theoretical air required is 14 times the fuel quantity available with you. Okay, so the answer at the end of the entire story or at the end of entire problem is going to be 14 kg. Or if this is a sample of say 100 kg, the amount of air required is somewhere around 1400 kg. The calculations involved here are rather slightly difficult to understand. Basic chemical knowledge is required, so on and so forth. But the answers are really uh, rather estimated in this case, I will say. Okay, so you can take help of all such answers, and you can solve the problems quite comfortably. Let us hope we will understand it step by step. So
Sir,
uh,
voice is low, sir. Voice.
uh,
No, I think it's audible.
It's clear for us, sir.
Yeah, it's audible, sir.
Okay.
so we go for case study, which is explained in the previous slide. That is the fuel. Different contents or constituents of fuel are given to us, and now we will try to see how to solve this problem. Our focus has to be on carbon first. They already, I told you that carbon after combustion will form CO2, hydrogen will form H2O, nitrogen and sulfur will form SO2, and all these chemical equations are to be considered for solving this problem. Okay, now we first consider combustion of carbon in the fuel. All the elements burn individually. Carbon burns to form CO2, sulfur burns to form SO2, and that all that. So ultimately now carbon will burn to form CO2. And here we have to revise our concepts related to atomic weight. Okay, so atomic weight of carbon is 12 and oxygen is 16. This we have learned probably in the chemistry of high school level, that the atomic weight of oxygen is 16 and atomic weight of carbon is 12. So ultimately, you need two atoms of oxygen for combustion. So 16 into 2 and carbon 12. So if you add these two, you will get answer 44. Now you will say that this is just arithmetics and this is just addition. What is new in this? But this forms a basic foundation or basic working of how much amount or how much mass of carbon is required to form the required amount of CO2. Okay, so ultimately 1 kg of carbon results into formation of 3.67 kg of CO2, and 2.67 kg of oxygen is required. All of you should Give a thought how I came to 2.67 and how I reached to 3.67.
So 12 kg of carbon here is there. We are calculating for the 1 kg. So all are
Right.
divided by 12.
Correct. Very correct answer. And I'm sure this is Patil, sir. Okay. So this is what is correct, because we are calculating for the 1 kg. So every entire equation is divided by 12. And that is how 32 divided by rather 12 will give you 2.67, and 44 divided by 12 will give you 3.67. That's right. So this is how now we have been given basically 100 kg of fuel. Mind well again. You can add all this, you will find that the answer is 100. Okay, 85 plus 12 is 97.9, and these all things uh, taken together it becomes 100. So out of the 100 kg you have got carbon 85.9 kg, and it will produce CO2 equal to 85.9 into 3.67, which is 314.96 kg of CO2. And oxygen required is again can be calculated immediately by you, and that is nothing but 85.9 into what, to work out the quantity of oxygen required. 85.9 has to be multiplied by what? Yes, or you can.
All the components, sir, like O2.
No. 85.9 has to be multiplied by what? To find out the oxygen required. Or what is the exact amount of oxygen required in this particular case? You can work
For
out.
one
For 100
for 1
kg,
kg, 2.67 kgs of oxygen is required.
Exactly. 85.9 into 2.67 is the required answer.
yeah.
Okay. Now I have come to 314.96 by the same thing. 85.9 into 3.67 is 314.96. That is why if you have got mobile in your hand, you can work out 85.9 into 3.67 is equal to what, and 85.9 into 2.67 equal to what. That will give you clear understanding of this first step of the problem. Otherwise, you will not understand anything in coming due course. So physical working helps a lot to understand. So please better you calculate on your own whether
Here,
I'm correct or not.
yes, sir. Here initially 1 kg of carbon we need to find out. So that is coming 2.67 kgs of oxygen is required,
Right, right,
and
right.
3.67 kgs of CO2 will
CO2.
produce with the help of.
Right, right.
And
So
whatever the available percentage in that content,
problem. Yeah.
that is 0.859 kg, we can multiply with that O2 and CO2.
85.9 you can multiply with 2.67 for finding out oxygen, and 3.67 for finding out amount of CO2.
Okay.
Okay. So this concept has to be repeated in next two steps.
Right.
Okay. So 2 times H2 plus O2. Again, this is a balanced equation. When we think of H2O, we just say that H2 plus O is equal to H2O. But chemically, it is not a balanced equation. That is the use of learning chemistry in our academics. So ultimately, we need to have a balanced equation, and this is that balanced equation. So ultimately 4 kg of hydrogen reacts with 32 kg of oxygen to form 36 kg of H2O. And then when we divide the entire equation by 4, we come to the conclusion that 1 kg of H2 will form 8 kg of oxygen and 9 kg of water. Again the same thing, right? Is there any doubt?
Sir, equation will be 2H2 plus O2 equal to 2H2O, right?
Right. That is my mistake.
Okay,
Yes.
okay. Okay, sir.
So this is how we can come to the conclusion that 1 kg of H2 can form 9 kg of water, and oxygen in that oxygen required for that process is 8 kg. So in this case we have 12 kg of water, which we are there, and we will be able to form 108 kg of H2O, and the reaction will require 96 kg of oxygen. So same thing will be repeated for sulfur again. Sulfur plus O2 is equal to SO2. But sulfur is quite helpful for our rather simplicity, because sulfur has got partially atomic weight equal to 32. And oxygen we always consider 32, that is 16 into 2, gives you SO2 equal to 64. So in this case, we have got 0.5 kg of sulfur. So we will need 0.5 kg of oxygen and we'll be able to get 1 kg of SO2. Okay. So now for combustion, if we want to find out the air required, what will we do? Now we have calculated oxygen required, but oxygen required is not air requirement. Okay. So every step, all these 3 steps we have uh, worked out how much amount of oxygen is required, and we can comfortably add all the 3 quantities, and then we can get the amount of oxygen required. Up to this, I think everyone is clear till this point. But now with the base of oxygen required, how can we find out the amount of air required? That is my question. Suppose if we know that oxygen required is say 200 kg for the time being, then how can we find out the amount of air? Yes.
Actual O2 required we need to calculate from all the
That,
3 equations
yeah, right. That is agreed. Yes. Then
and divided by the weight of the O2 in the atmosphere.
air. Yes. And that weight is considered as volumetric weight. And that is why it has to be divided by 0.23 and not by 0.21. Okay.
Correct.
21% is uh,
Volume based.
no 21% is mass based and 23% is volume based.
Sir,
Okay.
23 is weight based, right?
Oh yes, I'm sorry, again it becomes a
20.
confusion. 23 is weight based and 21 is volume based, right?
Hello?
Yes. Hello. Okay, so the same way we have proceeded further. Total oxygen required is the sum of all 3. That is 229 here, 85.67 into 2.67 will give you 229 answer, plus 96 here, uh, 96 plus 0.5. The answer becomes 325.5. But amount of air required is again here one more step is left. Oxygen already in flue gas is 0.7 kg. Okay.
Correct,
So
sir.
0.7 kg oxygen that is already present in the flue gas going out of the chimney. So that is deducted. And then we have come to the conclusion that oxygen total required by deducting the oxygen already present, we get 324.8 kg, and that we have divided by 0.23, which is equal to 1412.17, which I already explained to you that this answer is the final answer of the problem. You have got 100 kg of furnace oil and air to be supplied is 1412 kg. Okay. So ultimately it is 14 times. Conclusion: 100 kg of fuel will overall need 1412 kg of air for good combustion. Hence, air fuel ratio for fossil fuel combustion is 14 as to 1, and more precisely for this problem it is 14.12 as to 1. Okay. But for convenience you can say 14 as to 1. Now this is what we have to find out: theoretical air required for combustion. Now, similarly, we can find out theoretical CO2 required for combustion, but because CO2 has got atomic weight equal to 44. So ultimately, we can calculate in terms of moles, because these atomic weights are expressed in terms of moles. Okay. So this is the step 2 of that problem: theoretical CO2 required, and based on this, we can find out theoretical CO2 percent. Okay. So we have to find out other moles required. Nitrogen content in the air is this much, 1412, minus oxygen is 324.8, Mindwell, for this 324.8, they have considered 0.7 kg of oxygen already present in the flue gas. Okay. If in exam, instead of 324.8, if you take it as plus 0.7, your marks will never be deducted. Okay. The basic logic here lies in understanding that 1 kg of fuel will need 14 kg of air for combustion in case of furnace oil. So your answer should be in that range. It should not be very, very precise, and it should not be very, very accurate. You should have conceptual understanding. That is important. So atomic weight of nitrogen is 28, and that is why moles of nitrogen required are much higher. 187 divided by 28, you will get 38.84 moles. And again, for SO2, it is obvious that SO2 is 1 mole, and the atomic weight of SO2 is 64. So it is 1 upon 64, which is equal to 0.016. So theoretical CO2 equal to moles of CO2 divided by total number of moles present in the combustion. So moles of CO2 are 7.16, and total number of moles present are 7.16 plus 38.84 plus 0.016. Here, major role is played by nitrogen Mindwell. Okay, because quantity of nitrogen is also too high as compared to oxygen. So ultimately, 7.16 divided by all these three number of moles will result into theoretical CO2 percent equal to 15.56%. Uh, if this is very well understood to you, the next step in this problem is that they have tried to find out actual CO2 percent by using specific some certain instrument, and they have come to the conclusion that in laboratory analysis the actual CO2 percent is 10, and that is how excess air can be worked out based on the percentage CO2, and this is how the excess air is equal to 15.5 divided by 10, that is theoretical air divided by actual air. Theoretical CO2 divided by actual CO2, sorry, minus 1. Theoretical CO2 divided by actual CO2 minus 1. And if you want to find out in percent, you have to multiply by 100. So ultimately, excess air supplied is 55%. Thus, excess air quantity is 100 plus 55. That is the essence that how we must understand what is the concept of supplying excess air. Actual air to be supplied is 1412 kg, but you want to supply excess air for combustion in order to have efficient combustion. So you have in this particular problem, you have supplied based on the CO2 CO2 content. We could understand that you have supplied 55% excess air. So actual air supplied is 1412 into 1.55, and excess air supplied is 1412 into 0.55, which is equal to 766.85 kg. Is it right? Similarly, excess O2 supplied is 776.85 into 0.23. Here it should be by weight again, and it is equal to 176.68 kg. And excess nitrogen supplied is 776.85 minus 178.68, which is equal to 598 kg, 598.17 kg. So this is how excess air, excess O2 supplied, excess nitrogen supplied can be worked out. Is it clear? Any doubt for this problem?
Sir, I need to explain once more, sir. One more time.
Total problem.
Yes, sir. Yes, sir. Total slowly. Sir.
What I will prefer, what you say is correct. But what I will prefer, I will show you the slide again, and you ask me your specific doubts. That will be better, isn't it?
Yes, sir.
Okay, this is the problem statement.
Yes, sir. Yes. This is okay, sir. By
Yeah. You continue reading and tell me your doubts.
Yes. C plus O2 is CO2, sir. CO2.
Right.
So 12 into 2.
This is all atomic weight of individual.
Atomic weight. Okay.
Yeah, right.
Then this 85.9, sir. 85.9.
Huh. It is
Carbon.
mentioned in the problem that the fuel sample they have considered as selected of furnace oil as per the laboratory analysis. The carbon content in their fuel sample is 85.9%. Okay. If you take some other furnace oil from other sample, it may be somewhere near 85.9. It may be 84 in some case.
Yes.
Okay.
Then 2.67, sir. 2.
This is what I tried to explain, that you are using 1 kg of carbon. If you are using 1 kg of carbon, your oxygen requirement is 32 divided by 12. So
Yes, sir.
32 divided by 12 is 2.67.
Oh, okay. That's 2 divided by 2.
And same case for CO2.
CO2.
44 divided by 12.
44 divided by 2.
All of you can read it once again and all of you can ask the doubts, not only sir. Okay.
No, 2H2 plus O2 to H2O. Okay, that's 4 into 2 into 2.
It is balanced equation, na?
Balance. So 12 kg of water from 108 kg of H2O. So S plus O2. So 0.5 kg of sulfur.
Pramod sir.
Yeah.
Here they are calculating like 85.9% is for 100 kg.
Right.
So for simplifying the problem, if I convert that percentage into kg, 0.859 is for 1 kg. Correct?
Right.
So at 1 kg also I can calculate for simplifying the problem.
Right.
Same answer, only 14.13 only will come at the
Yeah,
end.
same thing. No doubt.
Total oxygen required, sir. Actually, we have to add all these oxygens.
Yeah.
Yes,
This is all
Satyanarayana
the
sir.
3 oxygens.
Yes, sir.
All the 3 steps. And
Here
oxygen.
main components, sir. Sorry, please continue, sir.
Continue, sir.
And in our problem, they have mentioned that flue gas contains this oxygen. Oh, sorry, furnace oil itself contains this oxygen. I'm sorry. Only the sample furnace oil contains 0.7 kg of oxygen. So that 0.7 we have deducted.
Acha, deducted.
So in the main
point-
all stoichiometric equation, sir, there are CO2 will form, H2O will form, and SO2 will form.
Right.
So in this, how much oxygen is required? That is important for us.
Yes.
With that, we have
Find out
to
amount
divide.
of air required.
We have to divide the available oxygen and then divide it by 0.23. We'll get the theoretical air.
Theoretical air. Exactly right.
So that is important, sir. For that
Yeah.
only these equations we are.
Yeah. This entire exercise is carried out for that sake. How much
Oxygen
amount of
requirement.
air is required? Oxygen and then air for your
Right,
combustion.
right,
And then next step after air, next step is for excess air.
Yeah.
Okay,
Because,
sir. This is okay, sir. Theoretical air understood, sir.
And this percentage CO2, sir, that is also very much important. Weight of that CO2 divided by total moles of the CO2.
Right.
So each mole is important for us
Right.
for calculating this percentage of CO2, percentage of S and everything.
Correct.
So mole of CO2 formula is weight of the CO2. Weight of the CO2 we got in first equation, C plus O2 CO2
Yeah.
equation.
Right.
We got 314.9 kgs.
Right.
So that is divided by 44 will give the
Which is
7.16
the atomic weight of CO2, right?
Correct. So each mole we have to calculate first, and then
Exactly.
for CO2 7.16 divided by total moles of the components.
Correct.
So that comes under 15.56%.
No, why we have to calculate this, sir? Moles of CO2?
There is a formula, so for calculating the percentage CO2, we need all the moles of the components. So mole of the component. Yes, sir.
Basically, we have found out amount of air required for proper combustion, but
Yes, sir.
we are not happy with the exact amount of air required. For efficient combustion, we need to supply excess air, and that how much excess air we have supplied, that is worked out here.
Oh,
Now, how much excess air? That answer is gradually we are getting here. This theoretical CO2 required is this much, but they have then mentioned actual CO2 supplied in the next slide.
so-
Percentage CO2 measured in the flue gas was found to be 10%. So that is how we could find out excess air, amount of excess air.
Sir, here normally in boiler we are using one more formula whenever there is available of CO2, measured CO2 and theoretical CO2. Correct, sir? So
Yeah.
that is 7,900 into theoretical CO2 minus actual CO2 by actual CO2 into 100 minus CO2. That is the formula. So this you have mentioned here, na, sir, 15.5 by 10 minus 1. So
Mhm.
this is also comes from that equation only.
Exactly. Yes.
Okay. So here
And this is
we can say,
simple one. This is simple one to use.
okay,
Simple one to understand so better.
okay. Here theoretical air by excess air minus 1. That is the formula, sir.
No, theoretical air by actual air,
Actual air. Okay.
which is 10%, which was measured by them in laboratory. Is it fine, sir? Now,
yes, sir. Yes, sir. Right, sir. Thank you, sir.
actually, I have taken 3 case studies in this entire topic. So this is first is over. Now you can go through case study 2, and case study 1 and case study 2 are almost all similar, but case study 2 is much simpler than case study 1. This is only this much. So I will insist you all to read, understand, and ask me doubts. That is much better, I feel. Okay.
Okay.
I can explain, but all these things we have covered in the previous problem. Any doubt in any step you can ask me, no problem. Okay.
Sir, here this problem is okay, sir. This problem is here we need one conversion is required, na? Quantity of the furnace oil they given in liter per hour, and also they given the specific gravity. So
Right.
mass of the quantity, if you want to convert into kg per hour, we need to multiply the specific gravity with the quantity of given in problem, right, sir?
That is why I wanted to specifically mention that if any problem expresses the mass or weight in liters,
Huh.
then that liter has to be first converted into kg, and when liter word comes into picture, it is very necessary to uh, to consider density of that particular plate. Okay.
Correct, sir.
So
Correct.
that is why this is a new idea or concept for this particular problem, that here they have mentioned in liter. Our previous problem was entirely in kg. Here
kg.
they are mentioned in liter. So as soon as liter comes into picture, we are concerned, very well concerned with density, so that liter can be converted into kg. Our all problems, as far as mass is concerned, kg has to be considered.
Correct, sir. This is not only for the paper 2, so paper 3 also will be applicable the same. Gravity
Actually, no. I don't
basic.
agree. I don't agree. The reason is that
Sir.
paper 3 is specifically for electrical driven devices.
A few cases, na, sir, even if you see the questions, they are giving the quantity in liter per hour.
Ah,
That's what in that context I'm saying.
yeah. Right.
Just for confusing the
No,
candidate.
actually, in all 4 topics, all these things are common.
Yes, sir.
But only thing, the distinction between paper 2 and 3 is that Paper 2 focuses on fuel driven devices, and
Correct.
paper 3 focuses on electrically driven devices.
Correct. Correct.
That is what the difference is. Otherwise, compressor is and HVAC are totally mechanical engineering parts, but they have taken it in electrical utility because they are electrical driven.
Correct. Sir, here a few questions I have seen in previous questions. One confusing question is like air to fuel ratio. All these things we have calculated, sir, and we got theoretical air and actual air supply also.
Mhm.
So once we got the actual air supply, they are asking for the volume basis for air to fuel ratio. On volume basis, they are asking, not on weight basis.
Right,
So,
right, right.
so that can you please explain, sir?
Actually, you just send me that problem on WhatsApp. I will give you my
Sure,
number.
sure, sir. I'll
So
I'll
we'll
post.
not cover it today because of
Yeah,
the time limit and all. But you send me that question and I will try to answer you.
yeah. Sure, sure, sir, sure.
So is this case study 2 is clear to all? What is new in this? Please let me know. Already during previous discussion, it is made clear that liter has to be converted into kg and density has come into picture in this problem. It is right. What else is new in this problem? Again, for your curiosity, I will say theoretical air required is again 14 kg of air per kg of furnace oil. In previous problem, it was 14.12. So I always keep on saying that the answer to these problems are very well known every time. Okay, they will not go beyond 14. The answer will never be 16. Answer will never be even 15 also. Plus minus 1. 14 plus minus 1.
Until unless that component percentage will change, na, sir.
Uh,
It
but
will be
uh,
it will be remain
but
same only.
actually for combustion it is quite
Same.
necessary to maintain all these parameters,
Okay.
and they give practical problems. So ultimately that manufacturer has also to maintain that particular composition in order to get good combustion.
In this problem, we are not calculating moles and all, no, sir. Moles of CO2, etc.
Yes, because they have not asked us about all this, and they have directly mentioned amount of excess air supplied.
20% excess.
This was not given in previous problem. If excess air is given, the task becomes easy.
So if we calculate also, that will come same thing, sir. 20%.
But all the data needs to be given. We have to check, compare with previous problem in that case. But excess air will come same. But again, exact in previous problem, try to recollect that they have mentioned actual CO2 percent in the laboratory was mentioned. Here that is not mentioned. Are you getting me? This
Yeah.
percent
Sure.
CO2 measured in flue gas, it is given in this problem, and in this problem it is not given. So you can't calculate it here. You may assume and you may get the answer, but it should be in that range only.
In the first problem also, it is not given, sir. CO2
What
is not given.
this measured in laboratory, na?
Laboratory is not given, sir. Only H2O.
Yeah. Actually, this is a solved problem in the book. In exam, they will have to take care for this. Okay, so it is clear to all of you, this problem.
Yes, sir. Yes, sir.
Can I go to one more third case study?
Third case study. Okay.
Third case study is very, very easy. This is to make your concept clear that excess air calculation can be very easily done if theoretical CO2 percent and actual CO2 percent are known.
We measured CO2 of 5 boiler. Flue gas. Theoretical CO2 percentage. Theoretical CO2 minus
Sir, as I said earlier, there was a other formula, right? And whenever the theoretical CO2 and actual CO2 is available, that 7,900 formula. So with that, I am getting 94%, and with this formula, we are getting 100%, right? So that 4% variation is there.
Formula you what formula you have used?
That in book they given us, sir, whenever the CO2 measured and CO2 theoretical is given, 7,900 multiplied by theoretical CO2 minus actual CO2 by actual
Ha.
CO2 into 100
This
minus.
this error is because of 7,900. In some cases, it can vary. The content of nitrogen can vary in the air. So your answer is not at all wrong, and you will not be considered as the wrong answer. Actually, in these all papers, they have a range of answer. They don't
Okay,
expect your answer to be in decimals.
okay, okay.
Okay, with all this, I think paper one, topic one for me is over. If you have got books and if you have something to ask, you can very well ask me, and we can clear your doubts. But as far as I am concerned, my PPT is over. Okay.
MCQs are there, no, sir, which
All MCQs we will solve immediately. Uh, just a minute. I will try to rather uh, bring it on my. Uh, I will
present.
share it with you, and then we'll solve. Just give me 2 minutes more for that. Okay. Yes, I think now it is visible. Is it visible? Hello?
Visible, sir.
Yes, sir.
Okay, we'll solve one by one. Great. First is which fuel requires lowest amount of excess air for combustion? Okay.
Natural
So
gas.
FO, LDO, coal and natural gas. We have learnt a lot about gases. Gases fuels are very easy for combustion and will definitely need lowest amount of excess air. So
Natural
that
gas,
is
sir.
natural. Right, right. Which fuel requires maximum air for stoichiometric combustion? Uh, Butane, propane are gaseous fuels, so they are ruled out. Hydrogen and coal we have to think of, but hydrogen requires more air because we have found out that 1 kg of hydrogen needs 8 kg of oxygen, isn't it?
Correct. Correct.
So I think hydrogen is correct, right?
Yes,
Yes, sir. Hydrogen is correct.
Right. How many kg of CO2 are produced in complete combustion of 16 kg of methane? Here, try to remember the tricky question thing that methane itself has got atomic weight equal to 16. Is it right?
Correct. Correct, sir.
Carbon is 12 and hydrogen is 1. So it is 16. So ultimately CO2 produced will be also be equal to atomic weight of CO2. So what
44.
is atomic weight for CO2?
40,
Yes?
44.
Right. So that is correct answer.
How, sir? How it is, sir? 44.
C plus O2 CO2 na sir.
Yes,
You're
sir.
right.
32, the 16 plus 32 plus 12 will give the 44 quantity.
Oh, 32 plus 12.
See, CS4
Molecular weight of CO2.
for CS4 methane they have taken exactly equal to atomic weight, isn't it? Is it right? Carbon is 12 and hydrogen is 4. So it is 16.
Acha.
So same weight is in CO2. Next, which agro residue has the lowest calorific value? By our just common sense, we can say that rather. Sawdust must have got lowest calorific value because it flies in air as such, isn't it? Sawdust is can fly in air, so ultimately you will not be able to easily combust it.
Yes,
Next,
sir.
Lowest calorific.
we can go to 5 now.
Yes, sir.
Which among the following releases the most energy per kg on complete combustion?
Hydrogen, sir.
Yes,
28922 kilocalories it will generate.
right. That is mentioned in even in the book and all. And
Sir,
actually, we
4
the
is sawdust, sir. Sir, sorry, sir.
4 is sawdust, right? That is what we are talking, right? Okay.
Okay, sir.
Now we go to 5. Uh, Hydrogen requires more energy per kg on complete combustion because again same thing, 1 kg of hydrogen needs 8 kg of oxygen. That is one thing which we have learned today, and the book has given specific amount that is released. It also shows the hydrogen. Okay.
Yes, sir.
Which among the following is most viscous? Uh, Viscous is easily pumpable or like water or like that, na? So water is easily no, they want to say fluid. I think
Viscous.
kerosene is correct or what?
Furnace oil.
Kerosene is lighter, sir. Furnace oil maybe, sir.
Furnace oil will be right.
Most viscous. Oh, right. I am extremely sorry. Viscous means the resistance to flow. Again,
Correct.
remember, viscous is the resistance to flow. So there
Yes,
is
sir.
no there should be no confusion. So furnace oil has got highest resistance to flow. I already explained that furnace oil is the lowest
Heating.
distillation portion of the petroleum refinery. That is lowest quality of fuel in the refinery. Uh, there is 7 stage distillation, 8 stage distillation, and whatever is the last stage, it is furnace oil. So ultimately, furnace oil is very, very thick if you see, and it is difficult to get pumped, and that is why it is most viscous, right?
And that is the reason we are heating the furnace oils also, no, sir? For some.
Yes, at the bottom of each every furnace tank, as it is, we need heaters, so as to make it viscous.
Yes, sir.
Next, content of solid left in the oven after volatile matter is distilled off while analyzing the composition of coal in laboratory is
Mix of carbon and ash, right?
correct. Correct. Ash will be obviously left and fixed carbon will be there, right? Oh, sorry again. Yes, 8th question. Na? 7 is covered. Which is the best suited pump for pumping LSHS? For all liquid fuels, best suitable pump is gear pump. No doubt. Rotary pump. Correct?
Yes, sir.
Oxygen percent measured in flue gas can be done by using
Zirconium oxide probe.
zirconium oxide probe. Why not potassium oxide?
Uh,
Potassium oxide is a chemical solution and zirconium is a alloy steel. So if zirconium is introduced in the probe where the oxygen percent has to be measured, it is measured by probe. So if zirconium is there, it will have resistance to heat and so many other things. So zirconium, we want resistance to heat because flue gas temperature, it has to withstand the flue gas temperature, right?
correct.
Now for complete combustion of every kg of your firing, this answer you all should give. Everyone should tell me
14 kg.
loudly.
14 kg.
Right. So I think we will finish and we will meet because I have to take 2 lectures today. Okay.
Okay.
So next lecture is scheduled at 5:15. So we will have a break, isn't it? If
That
you
is
want
which
to,
topic, sir?
next topic is boiler.
Yeah. Okay, sir.
Second.
So if you want to ask few questions, there is no doubt you can ask, or otherwise we will meet at 5:15. If you have any questions
This second one only I have to explain, sir.
in these objectives,
In the question, sir. Question in the first question is there, no, sir?
which fuel requires the lowest amount of excess air?
No. That's in the solid examples, sir. Solid examples.
Okay, solid
Moles of
example.
CO2, sir.
Okay.
Moles of
Again,
calculation of theoretical
right,
CO2.
right.
Sir, Satyanarayana, sir.
Sir.
I also have the same problem initially. What I have done, I myself have solved many times this problem. Once we go through the many times, na sir, then each and every part we will understood. This is somewhat tricky concept. We need practice, sir. Then
Acha,
only,
okay.
until unless if you are not practicing, na, this concept will not understood.
Correct, you are right.
Yes, sir. What do you want to ask in that?
No,
Case one, he is asking about, sir.
case one, sir. Case one, that moles are there, no, sir. Moles.
Percentage
Acha,
CO2, percentage CO2.
moles.
Up to theoretical air required 14.12 is okay, sir. That I understood.
Okay. Then this is the theoretical air required for complete combustion when you don't want to supply any excess air. What you can call it as stoichiometric air.
Stoichiometric air, right?
Stoichiometric air is 14 kg for
14
1
kg.
kg of fuel. But
1
you
kg
are,
fuel,
but for good combustion, you are trying to supply excess amount of air.
excess
So
amount.
ultimately, for calculation of how much excess air you are going to supply can only be calculated if you know theoretical CO2 percent and if you compare with actual CO2 supplied. So that is why you have to calculate theoretical CO2 required. And this theoretical CO2 calculation can be done with the help of the moles of CO2 in flue gas. Okay, this is the purpose of calculating theoretical CO2 for combustion. Okay, so now moles of CO2 in flue gas, that is quantity of CO2 you have used is 314.97 kg. Okay, and you can compare it with 44, which is atomic weight. So ultimately number of moles required are 7.16. Same way you can go for nitrogen, that is 1412 minus oxygen you can reduce deduct, and you can get 1087. Then 1087.5 will be divided by atomic weight of nitrogen, N2. Nitrogen itself has got atomic weight equal to 14, but you are considering N2, so it is 28. So what 1087.25 divided by 28 will give you 38.80 per moles. Same
Sir,
case will be
1087, how it has come, sir? 1087.
1087, the simple logic they have applied is amount of air supplied minus amount of oxygen supplied. हवा में ऑक्सीजन छोड़ के दूसरा जो बचा है वो सिर्फ नाइट्रोजन है. Actually there are other contents to a very low extent in the range of less than 1%. Okay, they say that here they have practically they assume that air only contains oxygen and nitrogen. So they have total amount of air is deduct minus total amount of oxygen gives you amount of nitrogen, right? So
Plus 0.5, sir. Plus. That also we
now
have to
up to nitrogen it is clear, na?
Yes, sir, clear.
And now we go
Sunlight.
to SO2, na?
Okay, sir.
Just a minute.
By 28. Moles of N2, 38.86, sir.
Is it clear? Nitrogen is clear.
Nitrogen is clear, sir.
Now for SO2 it is very simple. Sulfur has got atomic weight 32 and oxygen also has got 32. You are using 0.5 kg sulfur. So automatically SO2 formed is 1 kg. 0.5 kg plus 0.5 kg. SO2 is 1 kg. So 1 kg and SO2 has got atomic weight equal to 64. So it is equal to 0.016. Okay. So
Yes.
theoretical CO2 equal to 7.16 divided by all the three. Okay, which we have found out. So that is why it is coming to 15.56%. Now here we have to recollect that amount of oxygen and amount of nitrogen will differ by 5 times roughly, because oxygen is 20 and nitrogen is approximately 80, let us say. So ultimately this is what is happening. That is why theoretical CO2 percent is always less than somehow 20%. Okay, so it is 15.56%. But in actual practice they supplied only 10%. So this is how you could find out excess air equal to 55%. Okay.
15.6% is excess air required.
Correct. This entire initiative was taken to find out excess air, right?
But that is only theoretical CO2 percentage, no, sir.
Theoretical CO2 is 15.5, but they have mentioned actual CO2 equal to 10. So theoretical divided by actual gives you amount of excess air.
10 by 15.6, sir.
15.5 divided by 10, opposite. Theoretical divided by actual. So now if you write it, you will definitely understand it. But
Yes,
still, we have tried our best. Okay. If you want to ask, I have no problem. Okay.
Yes, sir. I understood, sir. I will read out once more and then do it.
Yeah.
Thank
Okay.
you,
So we'll go for topic 2 at exactly 5:15. Okay.
Okay, sir.
Hello. Audible and visible both, na?
Yes, sir. Yes, sir.
PPT visible and I am audible.
Yes.
Our total participants are around 10 or less.
I think 7 are there, no? Two are still joining.
Who are still joining.
Yes.
Only
Yes.
2 are expected to join. Okay.
Yeah, yeah.
So we can start comparatively, no problem. So we now switch to topic 2 from paper 2, that is boilers. Obviously, boilers is a also can also be called as steam generators in correct words. The simple logic is applicable that water is heated to convert it into steam. But for this simple logic, there are many complications involved in the process of boiler, which we will try to learn today. Only few will be able to understand. There are many complications in boiler as a whole. Lot of things are to be learned in boiler. Many people have learned many years in boiler. Okay, so ultimately we will go ahead. I just now told you that boiler is a vessel which converts water into steam. Same way they have tried to define. A boiler is an enclosed vessel that provides a means for combustion heat to be transferred into water until it becomes heated water or steam, preferably steam because it is a steam generating device. So ultimately, combustion heat has to be supplied to convert water into steam. There is there are three different qualities of steam which we will learn in this process. First steam is wet steam, second steam is dry and saturated type, and last one is superheated type. All these three types we will come across in the process. And the hot water or steam is then usable for transferring the heat to a process. That is what that generated steam can be used for any hot process, for any drying process, as well as for any chemical process which is to be conducted under pressure and all. So to meet the process parameters of pressure, volume, temperature, and to supply adequate amount of heat required for the process, steam is highly preferable. In the next topic of steam systems, we will learn why only steam is considered or why water is considered as suitable fluid for heating, why not others. So ultimately, the reasons are also very simple and clear that we will learn in the next page. But water is useful and cheap medium for transferring heat to a process. This is one of the important answer for that. As well, water is inert also. It does not react with any chemical to form some other chemical again. So when water is boiled into steam, its volume increases about 1600 times. This is a clear and surprising fact that when water converts to steam, the volumetric increases 1600 times, producing a force that is almost as explosive as gunpowder. It is something like bomb. Many people are afraid of bomb, rather steam or boiler. As in many people, those who do not go to boiler section also. They are maybe commercial or something, but they are totally under pressure or under intention that anything can happen at any time in boiler. So ultimately, this causes the boiler to be extremely dangerous equipment that must be treated with utmost care. And that particular word care is taken care by particularly IBR. IBR is Indian Boiler Regulations. That is our next slide. IBR has formulated some rules and regulations for running a boiler, and that regulations make the boiler use more safe. So whoever wants to operate a boiler in his premises, preferably he should, it is recommended that the boiler purchase should be IBR boiler. Non-IBR boilers are at the own risk. Okay. The process of heating of liquid until it reaches to gaseous stage is called as evaporation. This evaporation process is not only applicable to water, same thing is applicable to even milk also at our home. That is, we try to heat the liquid, but milk does not reach to gaseous stage again. But we heat the milk to rather remove the uh, bacteria and all that and everything. But boiling anything can also be called as evaporation. This is what I want to say. Heat is transferred from one body to another by the means of three different ways: radiation, conduction, and convection. I think all of you are rather acquainted with these three media. So I'll not explain the difference between conduction, convection, and radiation. If someone accidentally belongs to electrical, it is a possibility that he may not know. If it is so, please let me know. But conduction, convection, and radiation are three important medium of heat transfer and are quite common. So should I move ahead?
Yes, sir. Yes, sir.
Okay. So boiler specifications, they have specifically mentioned a nameplate of boiler, which is very, very important. When one says that our company or our establishment has got a boiler, we should be able to ask him the question at least what is the TPH of that boiler. So TPH is the MCR of that boiler. MCR is nothing but maximum continuous rating, and that MCR is decided on the basis of amount of water that gets converted into steam in 1 hour. So ultimately, it is expressed in terms of ton per hour. Here they have mentioned 10 TPH, but in market you can find the boiler capacities from 1 TPH up to 400, 500 TPH and like that. So it depends on your process requirement and so on. But again, in this nameplate itself, this F and A at 100 degrees centigrade has got a very, very specific meaning, and that meaning is actually related to sensible and latent heat. From means I will say sensible, because that heat is sensed by thermometer, and the temperature keeps on increasing as you keep on supplying heat. So this process keeps on running till 100 degrees centigrade temperature is achieved, again at atmospheric pressure. Very, very important word I am trying to use. So at atmospheric pressure, we say that water gets into converted into steam only and only when it reaches a temperature of 100 degrees centigrade. So that heat which is sensed by thermometer is called as sensible heat, and that is nothing but from. And then you have to keep on supplying it continuously at 100 degrees centigrade for much, much longer time and many times higher than that of sensible heat. But in that case, you do not observe any change in temperature or any change in thermometer reading. So that is at 100 degrees centigrade, or that is what is phase change uh, concept as far as boiler is concerned. So ultimately, the liquid 100% gets converted into gas during the phase change at 100 degrees centigrade in atmospheric situation or atmospheric condition. So that is why from and at has got very, very important meaning. Okay. Now rated working pressure for each boiler is different. Now since this is 10 TPS, it is 10.54 kg per cm square, but in some cases it may be less or more depending on the process requirement and so on. Now they have mentioned type of boiler, three pass fire tube boiler. Okay, that is heat transfer surface area is increased by making multiple passes like two pass, three pass, and so on. So that is three pass. and fire tube boiler means the tubes inside the boiler do carry fire with them. So ultimately tubes carry fire and the shell carries the amount of water to be heated. So whatever is a fluid carried by tubes is called as, is given the same name. So ultimately if it is a water tube boiler, the tubes contain water, and if it is a fire tube boiler, the tubes contain fire. So that is what is fire tube boiler, and here fuel used is fuel oil, and in recent times the fuel fired can be agro waste, any sort of agro waste, or coal also. Coal in a major sector like power generation and all. So the heating surface, actually one more rating here it should have been mentioned, surface area in meter square. Actually that is much important. If you see a IBR passing certificate of a boiler, they definitely mention surface area of that particular boiler in meter square. So ultimately surface area in meter square is also very important indication of boiler capacity and all details. So the heating surface is any part of the boiler metal that has got hot gases of combustion on one side. Here tube side what we are talking of for fire tube boiler, and water on the other side, that is shell side. Any part of the boiler metal that actually contributes to making steam is heating surface. That is why a surface area of heating is important. The amount of heating surface of a boiler is expressed in square meters and can be related to the steam raising capacity of the boiler, which we just now discussed. The quantity of steam produced is indicated in tons of water uh, evaporated, tons of water evaporated to steam per hour. MCR is hourly evaporation that can be maintained for all 24 hours. Now this capacity can be maintained particularly 10 TPS for all 24 hours for this particular boiler. F&A means amount of steam generated from water at 100 degrees centigrade to saturated steam at 100 degrees centigrade. See, these both the temperatures are same, and it is a change of phase. Okay, so this is about details about the boiler. And then what is IBR?
Sir, TPH means tons per hour.
Right, right. Please note down, TPH is tons per hour.
Okay, thank you, sir.
Good question. Okay, so IBR, we will try to understand what is IBR. IBR is a very common term in industry. Many textile owners prefer to have equipments which are non-IBR. They feel that the government agencies will do this, that, and that, which is all well known. But 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 it's very important that the safety part is taken care by IBR. It is really we have just now gone through that boiler is a sort of bomb, and that safety part is taken care by government under IBR. So ultimately, one should always prefer IBR boiler. IBR is boiler is having certain operating conditions which are mentioned over here. It is any enclosed vessel if it exceeds capacity of 22.75 liters. This is on basis of experiment that the pressure generated in this capacity of water and vessel is not too danger to cause any explosion. It is that way safe. So if it is less than 22.75 liters, like our, you can imagine our domestic requirement. If we heat water at our home, the pot contains 10 liter of water or something. Ultimately, that is much safer. So if it exceeds 22.75 liters capacity, then it is covered under IBR, and it is used for generating steam under pressure. We are going to get idea about one more equipment like similar to boiler but not exactly boiler. That is called as hot oil generator. Hot oil generator is also called as thermic fluid heater, wherein only temperature is maintained and pressure is not there. So ultimately, if pressure word comes into picture, it is a boiler, and IBR rules are mandatory. So IBR pipe means any pipe through which steam passes from boiler to prime mover. Here the prime mover word has got very situational meaning, I will say. So prime mover can be steam turbine for power plant. Prime mover can be process reactor for chemical process plant, and prime mover can be process dryer for say textile and many other industries. So if you want to dry your output product, you can use the steam, and that will be the prime mover for that particular boiler. So prime mover means any part of the equipment which you want to move with the help of steam. Nowadays, in rather practically, I observed that the boiler feed water pumps are normally turbine driven pumps. Sorry, steam driven pumps, you can say. So ultimately, they don't prefer to use electricity for circulation of feed water. That is, feed water pump is turbine driven or steam driven, you can say. So ultimately, in that case, the prime mover becomes a pump. So ultimately, it depends where you are going to supply the steam. So for steam piping oblique system, if pressure of the system exceeds, again pressure limitation is there. If the pressure generated inside the boiler is more than 3.5 bar or 3 kg per cm square above atmospheric pressure, and if the pipe exceeds 254 internal diameter, then connected fittings, and it includes connected fittings of steam pipe, then the entire piping system is covered under IBR. So ultimately, internal diameter of the any of the condition, if is exceeded, it is a IBR boiler. So ultimately, this condition is very rather simple. 3.5 less than 3.5 bar pressure is generally not required in industry on a large scale. Uh, Very few industries might be using. So ultimately, majority of the boilers are covered in IBR, but still in textile industry, hot oil generator is used and steam is rarely generated, and they don't cover it under IBR. There can be rather uh, rules or modification, and that rule may be required, I don't know. But many textile industries around it which are into dyeing process are not in IBR because of all such things. They are using thermic fluidizer in conjunction with boiler, and for both the equipments, coal is a common fuel. So types of boiler system is, first is feed water system, and second is now it is very important that and very simple to understand for all of us, that boiler necessarily has got separate system for water, so that the water from the source can be pumped up to the boiler tubes at the exit or discharge end. So there is a feed water pump requirement, and entire feed water piping is required, and feed water system is required. So that is important part of the boiler system called as feed water system. Secondly, fuel system. In correct words for thermal power plant, it is also called as CHP. CHP, you can rather remember or note down that CHP for power plants is nothing but coal handling plant. And similarly, AHP is also there, called as ash handling plant. So coal handling plant, ash handling plant are all related to fuel system. And then next is chimney. Chimney for the exhaust side. That is unburned fuel along with air gets converted to flue gas, and that flue gas is discharged through the chimney, and that results into the separate section of the boiler. So these are the three broad sections in a boiler. There are many other sections. There are many other things included in boiler, because boiler is a very complex thing. It is not so simple. There is a drum, there is a steam stop wall, there is steam traps, there is piping. There are many things included in boiler, which we will understand one by one. Next is types of boiler. Already we have discussed about fire tube and water tube boilers. Fire tube boilers can be accommodated in lower space, and the requirement is of the small type or medium type. But if a requirement is very high, if you want to generate huge power, if it is a power plant, Then generally water tube boilers are used for higher capacities. Maybe about 10 TPH in general water tube boilers are preferred. And last is package type boiler, wherein package is nothing but the entire unit packed in a single pack. So ultimately package boiler is generally used where the requirement is small and space is also small. So in that case, package boiler is used, and in many cases, package boiler is generally a fire tube boiler. So this is about the types of boiler. This is about the systems used in boiler. Like in IC engine, you can say you have got a separate fuel pump system, then separate cooling system, and so on. Like this boiler has got these three important systems: exhaust system, fuel system, and feed water system. And these are the types of boiler we discussed. And again, fuel feed can have these 3-4 different types, which forms a part of our future syllabus. That is fluidized bed combustion boiler. We'll go through this entire one by one. First is traveling grade stoker. So stoker means rather the equipment, handy tool or like that. That is stoker feeds the fuel into boiler, and the grate keeps on moving by conveyor, and that is traveling grate cut stoker. So uh, boiler, it is called as fireman, who feed the fuel into boiler like coal and all that. So with the help of stokers and all. So that is called as traveling grate stoker, where grate is a sort of furnace. Okay, then spreader stoker, where the fuel is spread along in the main surface of boiler, or in the main combustion area of the boiler. So that is spreader stoker. So these are two types of different stokers. And last one is pulverized fuel boiler. Pulverized fuel boiler, already I tried to explain that coal is converted into gaseous form, or in the uh, rather powder form, better correct words. So that is pulverized fuel boilers. And that pulverized fuel boiler has got a bed which keeps on moving as the temperature rises. And that is what is that such type of bed which is fluidized under pressure is called as fluidized bed combustion boiler. There are 3-4 types of FBC boilers, and all those details are to be covered in this paper 2 itself. If you see your book, this is the 7th topic, FBC boiler. FBC, the full form is fluidized bed combustion boiler. So that particular concept you will understand in topic number 7 for boiler. And these are all the systems by which fuel is fed to the boiler. Okay. Here I will like to introduce concept of supercritical boiler. Okay. A supercritical boiler, particularly before I go through that entire explanation, I will try to explain what exactly supercritical boiler is. And I hope that the term enthalpy is known to every one of you. And if not known, then I will again explain. Enthalpy is not term enthalpy is not known. Please speak up. Anyone?
Yes,
Or
sir.
all of you are, huh?
So explain, sir. Actually, we are electrical.
Enthalpy, na?
Yes, sir.
Yes, I will explain, no problem. So this is the initial basic term for heating process, enthalpy. Enthalpy is defined as total heat content of the system. But enthalpy cannot be measured with any specific instrument. Enthalpy can only be worked out with the help of STEM table. There is a We had come across the word log table in our school life and all that. Similarly, like log table, there is a steam table in which various properties of steam are mentioned, and enthalpy is specifically given in steam table. So ultimately, enthalpy normally is referred from steam table. So you will again have a question that sir हमको एग्जाम में लेके जाना पड़ेगा क्या steam table and all that. But nowadays they have changed the system, and they give enthalpy figures in your question paper itself. But it is much better to purchase steam table like log tables, that is costing not more than 40-50 rupees something, but that will give entire that will make your entire concepts about boiler very clear. All various terminologies, all various figures, all various parameters of boiler could be easily and comfortably understood with the help of steam table. So I would like to advise you all that you all should study steam table by purchasing it and studying it. And I would welcome you all to ask your doubts about steam table. So that steam table has got two types of enthalpies again. Enthalpy is total heat content of the system, and enthalpy cannot be expressed on its own. Enthalpy is expressed simultaneously with the help of two terms, pressure and temperature. So in a given boiler, a particular pressure is required of steam, and that particular pressure corresponds to some specific temperature depending on the application. So you can find out the enthalpy of any given steam when you know the pressure of the steam as well as temperature of the steam. So for knowing enthalpy, it is must to know pressure and temperature at a time for the given steam. That is very clear concept. Now enthalpy has got different types. First enthalpy is sensible enthalpy. Sensible enthalpy is already we have come across in case of water just now, that the sensible in case of boiler is nothing but sensed by thermometer and related to temperature. So ultimately sensible enthalpy is the enthalpy which is sensed by thermometer. So ultimately till the liquid gets converted into entry of gaseous stage is called a sensible part, and the entire gaseous stage part is called as latent enthalpy. So sensible enthalpy is sensed by thermometer, and latent enthalpy is not at all sensed by thermometer. It is exactly a phase change process, and in that process you keep on supplying heat, but thermometer remains steady and does not no temperature increase is noted by the thermometer, but you keep on supplying the heat, and that is what is the heat supplied in the phase change process, and that is called as latent enthalpy. So ultimately, total enthalpy is equal to sensible part plus latent part. Total enthalpy is equal to sensible enthalpy plus latent enthalpy. So this is what is the concept related to steam enthalpy and enthalpy of steam. Now, enthalpy of steam keeps on increasing, particularly sensible enthalpy I am talking of, keeps on increasing as the pressure of the steam increases. So ultimately, if you are generating steam at atmospheric condition, your sensible enthalpy is around 100 kilocalorie or 100 degrees centigrade. Both are same as far as steam engineering is concerned. So ultimately, sensible enthalpy is 100 kilocalorie, and as the pressure keeps on increasing, sensible enthalpy keeps on increasing considerably up to the supercritical stage. So what is that supercritical stage will be explained by me in few next minutes. So sensible enthalpy keeps on increasing as pressure increases, and the latent or hidden enthalpy keeps on reducing as the pressure increases. So ultimately, in latent enthalpy, just now I told you that at atmospheric condition, latent enthalpy is 540 kilocalorie for atmospheric condition. So in atmospheric condition, the latent enthalpy is at its top, and as your pressure keeps on reducing, latent enthalpy keeps on reducing. So there is a certain point, critical point, where the latent enthalpy becomes zero and sensible enthalpy is at its top, and that particular point is called as supercritical condition and supercritical boiler, and that particular point as mentioned here in the slide is 221.2 bar, and temperature is 374.18 degrees centigrade. See, the decimals do not matter at all. You can just say that 221 bar and 375 degree temperature. corresponds to supercritical boiler. Okay. So I have tried to explain supercritical boiler this way, that sensible enthalpy keeps on rising at that and reaches the top, and latent enthalpy keeps on reducing and it becomes zero at a moment when the pressure becomes 221 bar. So ultimately, this supercritical boiler has got many advantages which are mentioned here in the slide. That is, the heat transfer rate is higher at that level. Your heat supply becomes zero for latent part. So ultimately, the efficiency of the system increases. That is why the supercritical boiler is more flexible in accepting load variations. Ultimately, it can be run even at part load if it is a supercritical boiler. There is greater ease of operation involved, high thermal efficiency, normally expected efficiency of entire power generation system uh, when boiler is considered alone is around 35 to 36%, but here it is 40 to 45, 42%. So ultimately, thermal efficiency is higher in case of supercritical boiler. The absence of two-phase mixture minimizes the problem of corrosion and erosion, because they after supercritical point, the uh, liquid phase does not remain present and only gaseous phase is present. This minimizes the problem of erosion and corrosion, and your pressure remains steady. Steady pressure level can be obtained in case of supercritical boilers. So this is what is the concept of supercritical boiler. And for your information, in Maharashtra, the Koradi particularly is having Koradi power plant is having supercritical boiler. You might be knowing many more supercritical power plants. Actually, NTPC I have come across in Gadarwara, Madhya Pradesh. They are also having supercritical power plant, and they generate steam at a pressure of 280 bar, or in the range of 280 bar. So ultimately, as you go on increasing pressure, your performance of thermal power plants keeps on becoming excellent, but it has got many limitations as a whole, because a small industry boiler generating 10 bar is also much difficult to explain, to maintain for safety point of view. So ultimately, the risk of safety is very huge in supercritical power plants. So ultimately, supercritical power plants inspection takes place twice in a year. Okay. Now you can ask.
So
Yes.
two-phase mixer means
That is liquid and gas. There are two phases. So since sensible part is gone, liquid phase is gone after supercritical stage. Okay.
okay.
Sir, can you explain that supercritical point between the latent heat and sensible heat you just explained? Just few
Uh,
lights.
that is what at supercritical stage, the sensible enthalpy is at its top and latent enthalpy is just zero, because as pressure increases, latent enthalpy keeps on reducing. Okay. So supercritical state is the stage at which only supplying sensible enthalpy uh, up to 221 bar is advisable. After that 221 bar, you need not supply sensible heat. Okay. Sorry,
Yeah.
latent heat. I'm sorry. I'm extremely wrong. Latent enthalpy becomes zero. So ultimately, after 221 bar, you have to only keep on supplying sensible heat. Right? After 221 bar or supercritical stage, you have to keep on supplying sensible heat. Latent heat has become zero. Again, I will try to just read. If water is heated beyond above condition, steam parameters are called as supercritical. A boiler producing steam above critical pressure is called supercritical, while subcritical boiler has three distinct sections: economizer, evaporator, and superheater. The supercritical boiler has only economizer and superheater. Evaporator is not there, because evaporation process is a process where liquid is just converted into gas, and that part is over, because you are just uh, sorry, in evaporation section you are only supplying latent heat, and you don't want to supply latent heat afterwards. So ultimately, evaporator part is gone. in supercritical boiler. Actually, there is a diagram in next. Oh God. Okay, in the book there is a diagram which will make your concept clear. But as a whole, I think you have understood what is supercritical boiler,
Yes, sir.
considering sensible and latent enthalpy. And for more details, I will advise you to again study the steam tables. Okay, stream tables can explain in more details, because you will find that as pressure increases, sensible enthalpy keeps on rising, and as pressure reduces, pressure increases, latent enthalpy keeps on reducing. And in steam table, you will find that at 221 bar, latent enthalpy is 0 and sensible enthalpy is maximum. Okay, so that will practically, that table itself will practically explain you the concept of supercritical boiler. Even then, I have tried my best. Okay.
Yes, sir. Yes. Thank you, sir.
So the steam tables are available online to download.
I'm doubtful. In Google, if you, as per my rather experience, in Google, if you just type the pressure and temperature, you get the enthalpies in steam table in Google. But steam table as a whole, I could not yet get. You can try.
Okay.
Okay.
Yeah.
Because steam table has got again two different things. uh, that is sensible enthalpy is expressed in kilocalorie, that is mks units as well as SI units. Steam, that is enthalpy expressed in kilocalorie, also enthalpy expressed in kilojoule. There are two different units. So ultimately you may get a table mentioning values in kilojoule, but you may need it in kilocalorie and so on. There may be few different obstacles. Okay. So this is about the supercritical boiler concept. Now we will talk about evaporation ratio of a boiler. Okay. Actually, here the SEC mentioned is very important for energy sector. Particularly we energy auditors, wherever we audit a given industry or a designated consumer, the main important concern of energy audit is to reduce SEC. SEC is nothing but specific energy consumption. Okay. So specific energy consumption is very important term for all rather industries and specifically designated consumers. Here I will mention you important designated consumer like steel plant. Actually, consumption of electrical energy and any kind of energy is much higher in all various melting plants. If it is melting steel, the energy requirement is quite high, because uh, the melting temperature of rather steel, which is around 1539 degree. If you remember iron carbon equilibrium diagram from metallurgy, you will remember that 1539 is degree centigrade temperature is the temperature at which iron reaches ACM phase. So ultimately you have to achieve that temperature for melting, and that can be achieved only from, that has to be achieved from atmospheric condition. So you can imagine the delta T is around more than 1500. So if delta T is more, obviously MCP delta T is more and energy requirement is more. So ultimately wherever steel is melted, the monthly bill of steel plant is in crores of rupees. I had come across the bill of Steel Authority of India Limited as a practical experience once, that they are paying 30 crore rupees per month as the electricity bill. Steel Authority of India Limited at Chandrapur. Just to get a visualization and practical idea, I tried to mention this. So ultimately, the in all such plants where the who are designated consumers and who are consuming electricity and fuel on a very large scale, it is a tough task to reduce SEC, that is specific energy consumption, and that is what is the point of concern for all energy students and professionals. Okay. So SEC is a very important term to be remembered by all energy students as a whole. So SEC is nothing but specific energy consumption. So ultimately, for steel plant, specific energy consumption can be expressed as kWh of electricity consumed per ton of steel produced in a given day. Similarly, for boiler, SCC is steam to fuel ratio. Okay, how much amount of steam is generated at the cost of or at the expense of fuel consumed. So ultimately, steam is generally expressed in TPH in a, we just now came across in the nameplate. So steam is expressed in TPH, tons per hour, and similarly coal can also be expressed in ton per hour. So TPH divided by TPH. So boiler steam to coal ratio has got no unit, and evaporation ratio also has got no unit, and evaporation ratio is equal to steam to fuel ratio. Okay. So this is one more concept, evaporation ratio or steam to fuel ratio. For boiler it is same. And in paper 3 you will learn the same thing of SCC about HVAC system, that is air conditioning. But for boiler, evaporation ratio is very, very important, which is nothing but SCC or steam to fuel ratio. Evaporation ratio monitoring is best suited for any boiler when its performance is compared on day-to-day basis as a performance indicator, and daily consumption of water as well as daily consumption of fuel is recorded and recorded in logbook by all shift in charge, all shift officers in each and every industry, I will say. So ultimately, many industries are trying to achieve the benchmark value of SCC, that is called as benchmark SCC, and uh, these benchmark values are to some extent mentioned over here. Okay, so given that the enthalpy given in steam and fuel calorific value remain constant, because enthalpy, that is your steam requirements are constant and fuel calorific value is also constant. Particularly they have specifically mentioned it cautiously because coal GCV keeps on varying in a given day itself. If you use different coal from different trucks, obviously the coal GCV is expected to change. So on a, it is normally worked out on an average basis. So a drop in evaporation ratio indicates a drop in boiler efficiency. So ultimately evaporation ratio should be on higher side. And here typical values of steam to fuel ratio or evaporation ratio are mentioned. So if it is a biomass fueled boiler or agro waste fired boiler, the evaporation ratio is between 2 to 3, and the best evaporation ratio obtained in case of briquettes and all other agro waste is around 3.5. 3.5 is the benchmark value for biomass fired boilers. Similarly, for coal fired boilers, the benchmark value is 6, but it ranges normally between 4 to 5.5. In case of oil fired boilers, the benchmark value is 14, and it lies in this range. And for gas fired boilers, the benchmark value is around 13.2 or 3, and it lies in this range. Is it clear? Any doubt?
No, clear, sir.
Clear. No? So ultimately, we have to learn in boiler that this concept of enthalpy in all details, and the evaporation ratio, specific energy consumption, and specifications of boiler in all details. Okay. So I will move to next slide. Okay.
Okay, sir.
Now here I have directly switched over to performance evaluation of boiler. There are two methods of performance evaluation for boiler: direct method and indirect method. Direct method is very, very, very simple to understand and easy to follow, and everyone will be happy to learn direct method of that is method of finding out direct efficiency of a boiler by direct method, you can say. But indirect method is slightly rather complicated, and that we have to cover today. Direct method can be very simply understood, which we will cover just now, and then we will take numerical on indirect and direct both methods, but indirect method I'm yet doubtful. We will try our best that you will understand it. Okay, so first we will focus on direct method. The direct method is simply based on the concept of output upon input, and output of any boiler is amount of steam generated multiplied by particularly enthalpy of steam. So mass into enthalpy of steam is output of a given boiler in terms of kilocalorie per hour. Okay, so mass of coal used and mass of steam generated into enthalpy drop for given boiler is output of a given boiler. That is what is explained over here. Performance is nothing but output energy by input energy. Thus, in our case, we get steam as output, for which quantity of steam generated has to be measured in kg per hour, or in many cases TPH. That is why TPH is important term in boiler. For this, steam flow meter needs to be installed to get accurate value of steam generated in any given hour or any given day. Okay, so steam flow meters are must, but in majority of the cases in industry you will find that they do not have steam flow meter. Then how they measure the amount of steam generated? Is there any clue with you? We don't have steam flow meter, but we want to know how much steam is generated in a given time, given day, given hour. How can you do it?
So measure the velocity and area into velocity we can.
That will give you mass flow. Okay, okay. Okay. That is a good method, but measuring velocity will again need velocity meter. I'm trying to reach to a condition where I
Feed
don't want
water
any
flow.
portable instruments rather.
Feed water.
Very correct answer. Feed water, amount of feed water consumed is equal to amount of steam generated, because this is the reference from law of first law of thermodynamics, that is energy can be converted from one form to another form. Here we are converting water into steam, so this is water form is converted into steam form. So same amount of water is consumed, which is equal to amount of steam generated. So ultimately this majority of all in almost all industries are finding out amount of steam generated that is equal to amount of water consumed. There are certain errors in the process, because some of the water may get lost in the process, like blow down and all that, but that loss is negligible in the range of 0.5 to 1%. Okay, so all those losses are rather neglected, and only amount of water consumed is treated as amount of steam generated. So that is what is the uh, general idea of finding out steam generated. Now, many industries, that is what I have already said. One can apply first law of thermodynamics, and water supplied from each source may be accounted by installing water meter at each location. Feed water can be obtained in kg per hour, or even meter cube per hour, or ton per hour. Okay, because 1000 kg is equal to 1 meter cube, and 1 meter cube is equal to 1 ton for water. I think this concept should be clear to all of you. Okay. Now, apart from mass flow, again we have to find out as output enthalpy drop, and enthalpy drop has to be basically referred from steam table. So enthalpy drop has to be measured based on pressure gauge readings and steam temperature readings, because enthalpy can be found out with the help of pressure and temperature. So as per IVR rules, every boiler has got a calibrated pressure gauge. So ultimately pressure gauge readings are always available, and for temperature it is very simple to have digital thermometers and so on and so forth. So ultimately you can comfortably get temperature readings of steam, so at the point of delivery. And as well as return side, we can take the temperature of feed water, which is equal to which gives you return enthalpy, and so enthalpy drop is equal to H1 minus H2, and that can be measured in enthalpy has to be measured in kilocalorie per kg. Same unit is applicable to gross calorific value, kilocalorie per kg, for given fuel. So ultimately kilocalorie per kg is very, very important unit for us. Similarly, for input, mass of fuel is expressed in terms of kg per hour. That is kg of coal feed in the boiler per hour, or kg of furnace oil used per hour, and all that. And GCV of fuel is measured in terms of kilocalorie per kg. Remember very well, this input is a denominator part and this output is a numerator part. This is from here up to here, it is output part, and last two lines are for input part. So this divided by this is equal to efficiency of a boiler. Okay. So in the next slide, here I have taken up a case study, and the concept is very clear. They have asked evaporation ratio. Okay. You please read this problem and let me know what is the evaporation ratio for this boiler. Evaporation ratio, already I told you, steam to fuel ratio. So based on this content, you should be able to find out what is the evaporation ratio for this boiler.
Could your steam generator rate? Steam.
Yes, any answer?
4.4.
Very good and very correct. 4.4 is the steam to fuel ratio. And if you refer to the previous slide, you will find that coal fire boilers has got 4 to 5.5 as evaporation ratio, right? Actually, if a boiler is highly efficient, the value is expected to be more than 5.5. Okay. So this is how your answer is correct. Now we go to efficiency part of this particular boiler. Now output is steam 8 TPS and enthalpy drop is also mentioned. What is exactly enthalpy drop here? Enthalpy is measured in kilocalorie per kg and already it is mentioned. So what is the enthalpy drop for this particular case?
665 minus 85.
Right.
How it is, sir? How it is actually?
Again, you are generating saturated steam at 10 bar is your output steam, and that is, it has got enthalpy equal to 665, right? And we have to consider the return enthalpy, that is after condensation, that water is supplied to boiler as a feed water, and it is at and it is having enthalpy equal to 85 kilocalorie per kg. So this is the enthalpy of supply side, this is the enthalpy of return side, and that is why enthalpy drop is the difference of the two, right? So numerator is 8 into 665 minus 85. Is it correct?
Output of steam generator.
Yes.
8 in terms of TPH and delta H in terms of 665 minus 85, right? Now we turn to the denominator. Denominator gives you quantity of fuel consumed equal to 1.8 TPH. I am purposely not converting ton in in kg, because steam is also expressed as TPH and fuel is also expressed as TPH. So we did not disturb those units. Okay. So in the denominator it is 1.8 and calorific value of coal is mentioned. What is that?
Way to calorific value, sir. Calorific
G.
value 3200.
Correct. So in the denominator you will have a 1.8 into 3200. In the numerator you will have 8 into 665 minus 85. Isn't it? Is it right?
Yes, sir. Yes, sir.
Yes,
So
sir.
you should be able to find out the efficiency just now, immediately.
80%.
Very correct answer. Is it clear to everyone? And those who are unable to get, this is that correct. Okay. Any doubt in this problem? This is the method of finding out direct efficiency of boiler. This is the way in which numericals are asked in the exam for direct efficiency. Okay.
No, heat output means sir output that one. Acha, Q into.
You can express in terms of Q or ms. Both the things are same. I have purposely taken it as ms because mass of steam, easy to understand, instead of Q. I have taken purposely ms because mass of steam will be more easy.
Quantity. Okay, sir. Okay, sir. Understood.
Both the things are clear.
Mass of steam, mass of fuel. Okay.
Direct efficiency as well as evaporation ratio.
Yes, sir. Yes, sir. Mass of steam.
I have specifically added in the conclusion part that the benchmark value for coal-fired boilers of evaporation ratio should be 6. Here we have got it 4.4. And same way benchmark value for FO/LDO fired boilers, the evaporation ratio should be around 14. Okay. These are all the ideal or benchmark values. Okay.
The evaporation 8 by 1.8, sir.
Right.
Kind of steam generated by.
That is what is mentioned over here. Quantity of steam generated and quantity of fuel consumed. Okay.
Okay, sir.
So now this is a direct part, which a direct efficiency method, which we have tried to understand, and I think it is very clear to all of you. Okay.
Yes, sir.
So direct efficiency can be very easily worked out once you stand in front of a boiler on site. And if you have got steam table in your pocket under the two conditions, you can very easily work out direct efficiency with your knowledge of formula and all that. So there are advantages of direct method. What are those? Plant people can evaluate the efficiency of boiler quickly, and people like us can immediately evaluate with the help of all formula and all that. Requires few parameters for calculation and computation, and needs few instruments for monitoring. Okay. If you have got water flow meter, you can understand the quantity of water. If you have got if your all fuel is being weighed on the weighing scale, you can at least monitor the fuel consumed in 1 hour or 1 day, whatever is convenient to you. Okay. And based on that, you can also work out for the steam generated in 1 day or 1 hour, whatever is convenient to you on site. Okay. So that is all advantage of direct method. Now, what are the limitations? Particularly, all of you might be knowing about the blowdown of a steam or not. What is blowdown?
No, sir.
Okay. So, particularly as far as water is concerned, water gets converted into steam. It's very simple to speak and even visualize. But practically, water quality plays very important role in boiler. And the quality parameters of water have got a huge impact on the boiler performance. So the important parameter of water quality that impacts on the boiler performance is rather hardness and TDS of a feed water. So TDS of a feed water means what is the full form of TDS for water?
Total dissolved salts.
Very good answer. So ultimately, total dissolved solids in given boiler should be rather as low as possible, and particularly if you are using demineralized water, and if DM water is working at its best, then the TDS of that DM water is rather equal to 0, and that is why the water is more in its most pure form. And if there are certain contaminants in the water, your boiler performance will obviously drop, and maintenance problems will obviously increase. Okay. So this is how the blowdown is given to all boilers, almost all, based on the way in which TDS keeps on increasing. So TDS is total dissolved solids. As water boils and gets converted to steam, it is the TDS keeps on increasing, and at a specific level of TDS, there is a blowdown to be given to the boiler. Many industries keep a practice of giving blowdown once in a shift. Many industries install automatic blowdown system by which TDS of the water is removed along with the steam, and that is why the water amount gets lost in the process of blowdown, which is not considered in the direct efficiency method. Okay, so that is what is the accuracy of steam flow measurement and fuel measurement are supposed to have errors, particularly due to blowdown. Steam quality assessment in case of saturated steam conditions is prone to error. Steam quality like wet steam and saturated steam, superheated steam. Sometimes your steam may get wet because of many different reasons, which you will not consider in your calculations. The reported efficiency gives only values with respect to design, but it does not indicate any improvement opportunities. Uh, Now you could tell me that the boiler is 80% efficient, but you could not tell me why 20% is lost and where it has gone. So that is the point which they have mentioned here. So ultimately, that 20% contributes to what is the amount of losses in different ways, and all such losses like L1, L2, L3, L4 are considered in indirect efficiency method. Individual losses are found out L1, L2, L3, L4, and 100 minus all those losses is equal to indirect efficiency of a given boiler. So that is the concept of going for that is the concept of arriving to indirect efficiency of a boiler, and that is what we are going to learn in indirect efficiency. So indirect efficiency of a boiler consists of all such losses, that is 1 minus sum of all losses. What are those losses? The first important loss is the loss going to the dry flue gases, or the getting converted to all pollutants and flue gases. Particularly, you all must know, have the concept clear that flue gas is equal to air, amount of air plus the amount of unburned fuel for a given boiler. So ultimately, the flue gas loss is equal to amount of unburned fuel plus the amount of air that is gone to exhaust, or uh, rather chimney. So that is L1 loss, which forms a major loss part of the any combustion process. Your two-wheeler, four-wheeler, etc. has got a. If you have studied heat balance sheet of IC engines, the major loss occurs in the exhaust side through the exhaust gases. That is why there are many rules related to the exhaust of petrol engine, diesel engine, and so on and so forth. So similarly, here the major loss is gases going towards the chimney, going out towards the chimney. That is L1 due to the dry flue gases. That has to be worked out on priority in case of indirect efficiency. Now L2 is the loss due to moisture in fuel and combustion air. So moisture absorbs certain amount of air due to certain amount of heat, which has to be removed from the system. So if fuel has got moisture, the amount of loss is obviously more. If the air has got moisture, particularly in rainy season, the amount of L2 is more. L3 is the loss of heat due to combustion of hydrogen or moisture in the fuel. So moisture in fuel, moisture in combustion air, all these affect to the loss of the boiler efficiency. Then L4 is the loss of heat due to the radiation, that is in the furnace. For any given boiler, the temperature, particularly for coal-fired boiler and all, the temperature inside the furnace where the fuel is heated and water is converted to steam, that temperature inside the furnace is around 800 to 900 degree approximately. So that temperature is supposed to get rather supposed to get lost due to radiation in the form of electromagnetic waves. So ultimately, that loss due to radiation is treated as L4. It is generally assumed around 1 to 1.5%. So we need not worry much about this, but we have to worry about these three losses a lot for finding out indirect efficiency. And L5 is the loss of heat due to the unburnt fuel and all. So that is L5. And our direct target of indirect efficiency is 100 minus all these losses. So now, if a problem is given to you to find out the indirect efficiency of a boiler, you need ultimate analysis of a coal or fuel, mentioning hydrogen, oxygen, sulfur, carbon, and all that. That is, fuel analysis is required. Ultimate co-analysis, you can say. Even proximate analysis mentioning percentage moisture and all that is important for finding out L2 and L3. So percentage O2 and CO2 in flue gases is required. So flue gas content has to be known, and how much O2 is going out of the chimney and how much CO2 is going, that must be known. Now the flue gas temperature forms very important part of a boiler performance. Okay. In general, it is advised that for coal-fired boiler, the flue gas temperature should be more or less equal to or must be less than 110 degrees centigrade. Particularly less than 100 is not at all preferred because of the moisture content and the effect of moisture on various metallic parts. So ultimately, flue gas temperature should be in the range of 100 to 110 for particularly solid fuel boilers containing lesser amount of sulfur. Particularly for the liquid fuels containing sulfur to certain extent, the flue gas temperature can be even more than 150 or 160 degree or even up to 200 degree. It is a relaxation because of the sulfur content, because the dew point of sulfuric acid formation is 140 degrees centigrade. Okay, so that is about flue gas temperature. Next is the ambient conditions and humidity of air when the readings are taken. Next is GCU of fuel in kilocalorie per kg. Next is percentage combustible in ash, that is carbon content in ash and so on. And GCV of ash in kilocalorie per kg. That will give you loss due to the ash and all that. So all the things rather getting wasted in a process of combustion are to be considered, and all the losses are to be deducted from 100 to get the efficiency. That is what is the concept of indirect efficiency of a boiler. Is it right?
Yes.
Should we go ahead? Now we will start with the problem. This is the case study. Before that, if you have questions, you can ask, so that indirect efficiency is typically a difficult part. That is why I am trying to take you to the point as slow as possible. Okay. So we will move ahead.
Yes.
So these are all the data given for finding out indirect efficiency of a boiler, which I have just now mentioned. So you can immediately go through and tell me your opinion. Now, specification of that boiler, that is 20 TPH, is very necessary and important thing. Steam pressure generated inside the boiler is 66 kg per cm square. For your information, kg per cm square is equal to bar. So in some cases, if 66 bar is given, you should not say that the unit is wrong. Okay. 1 bar equal to 1 kg per cm square, you may note down and you may remember forever. There is no hassle of conversion in this process. Only if they give it in megapascal, then 10 kg per cm square equal to 1 megapascal. Okay. So that is about steam pressure. Now flue gas analysis as expected is given in detail. O2 content is 9%. Already I told you that O2% should be less than 21 and as low as possible. Here O2 content is 9%. Carbon monoxide in flue gas is 800 ppm. What is the full form of ppm again?
Parts per million.
Very nice. So this is part per 10 lakhs or parts per billion. CO is 800. CO2 in flue gas is 10.67% CO2 content. Average flue gas temperature is 180 degrees centigrade. Okay. Since they are using coal, the flue gas temperature is much higher. Okay, and they have got a very good chance of waste heat recovery, and they can improve the performance of this boiler. So ultimately, flue gas temperature is indicator of boiler performance. So ultimately, when you go to any industry and see the boiler, first point of attack should be flue gas temperature, which indicates lot of things for boiler performance. Here we can directly say that this boiler is underperforming or the efficiency can be less. Atmospheric air and ambient temperature considered as 29.3 degree, humidity in ambient air equal to 0.019 kg per kg of dry air. Okay, now this is fuel analysis. Content of fuel, carbon content is this much, carbon in coal in some cases we have taken as 40 to 41%. Here the carbon content is more, so expected efficiency figure can be good, but flue gas temperature is higher, so ultimately there is a chance of improving the efficiency. Hydrogen is 3.25%, nitrogen is this, oxygen is this, sulfur is this, and DCV of coal is this. Important is carbon percent, hydrogen percent, okay, and all that. Ash analysis is this. Unburnt in bottom ash 0.11%, unburnt in fly ash is 4.89%. Bottom ash has got GCV equal to this, and fly ash has got GCV equal to this. Okay, all these things are least important. The important factors are carbon percent, hydrogen percent, nitrogen percent, oxygen percent, and sulfur percent, and flue gas in O2.
So
Yes.
what is the difference between fly ash and
Bottom ash? Good.
Like,
Yes, yes. In the chimney, there is a particularly in the boiler there is ESP installed. ESP is called as
Electrostatic
precipitator. Electrostatic precipitator. So whatever precipitates is called as bottom ash. Okay, and whatever flies is fly ash. So ultimately, ash going out of the system is fly ash, and whatever you can precipitate you with the use of ESP is bottom ash. That is much easy to understand, I will say. Okay.
Yes.
Next. So should we go to the next slide?
Yes, sir. Yes.
You should remember to the God before going to the next slide. Okay. So this is the next slide. So this solution consists of 5 steps. Okay.
Yes,
And
sir.
the answer is this. Again, we had find out 80% efficiency. Same problem is solved with indirect method, and our answer is this. Again, I will say the final answers are quite good and quite estimated or can be estimated. But inside story is really difficult. Particularly in the entire paper 2, this indirect efficiency part is much difficult. And as just now one of our friends said that he solved the problem of fuel on paper and he could understand it properly. Same case is applicable here. Even if I explain to you in all details, you will not be able to understand this indirect efficiency method just now. But if you solve it on paper, you will understand many things out of the indirect efficiency. Still, I will try my best. Let us see how best you can understand. So now there are first few steps, 4 steps. Actually, our attack is finding out L1, L2, L3, L4, L5. And then we have to deduct all those from 100. So ultimately, our problem should start at step 5. But before that, we have to rather complete 4 steps. And those 4 steps are related to theoretical air required, actual air required, and excess air calculation, which is important part which we have learned in paper in topic 1. Okay. So first is find theoretical air requirement. Then next is excess air supplied. Next is actual AS, actual mass of air supplied. and based on that excess air. So first 3 steps are clear, and fourth step is actual mass of dry flue gas. This dry flue gas mass will be helpful to find out the loss due to the dry flue gas. So these 4 steps are very crucial to reach to the answer. Okay. And the first step we are now going to start is find out theoretical air requirement. And for this formula is to be practiced, not learned by heart. Again, mind my words. You have to practice this formula. You will not be able to do it by heart, and I don't expect it to do it by heart. Okay. So ultimately, there is no other solution to that. I am also helpless. But you have to remember that theoretical air required can be found out by this formula. L1.6 into C plus 34.8 into H2 minus O2 by 8 plus 4.35 into S divided by 100. That is per kg of coal. Again, you try to remind, for furnace oil, we said that 14 kg of air is required per kg of coal theoretically. Here also, for coal fired boiler, 7 kg of air is required per kg of coal. But the calculations involved are this. Okay. Here, the putting these values is very easy, but remembering this formula is rather difficult. Okay. Now here carbon 53.65. We have got a backup for this. If you remember, if you just go through the problem, carbon is 53.65. That is why it is 53.65.
That is given.
Okay. Now 11.6 is a constant for this particular air requirement calculation. Plus 34.5 into H, hydrogen is 3.25% in the problem. This is what I already told you, that these 5-6 values, this O2 in flue gas, CO2 in flue gas, and the capacities and all that, it is very important. Rest of the things are slightly important, not much. Okay.
These constants, how it has come, sir? Just some idea, some 11.6, 34.8, 8.68.
That idea is nothing but practice. And second thing,
Sir, I think it has
approximation.
come from ultimate
We have done
analysis.
in
Yeah.
I think it might have come from the ultimate fuel analysis.
All these figures have come from ultimate analysis. But again, ultimate analysis can give you the figure of carbon, hydrogen, but these constants in the problem are to be remembered. There is no other choice, I believe. What do you think? This carbon is from ultimate analysis of coal, right? Hydrogen is also from ultimate analysis. Oxygen is also same way. Okay. This sulfur is also same way from the ultimate analysis which we have referred in the previous slide. We can rather cross check, that is not a problem, but writing it will help a lot. I suggest that you should solve at least 2 to 3 problems by writing physically. Then only you will automatically learn the logic.
So this is 7.0 kg of coal. Wait for
This is
complete.
the final answer, which is quite very well expected. Okay.
No.
And even if your answer is say 7.2 or 7.1, that is not a problem. But it should not be much higher than 7 kg. That it should not be 15, 16, 18 like that. So this is what is the step 1. You have to find out the theoretical air required, and the values are put as per the analysis given in this particular fuel analysis. Okay.
Yes.
Fuel analysis and flue gas analysis both are required for finding out indirect efficiency. Okay. So step 1 is hopefully clear to you, and it will be more clear after practice. It is very
Okay.
simple. Now go to step 2. to find out excess air supplied. Now the problem gradually goes on becoming simple, but again step 4 is slightly critical. Step 2 is very simple. You to find out excess air, you just have to refer to this formula O2% upon 21 minus O2. 21 has got a great significance that air contains 21% of by volume.
Oxygen
By volume.
by
So,
volume.
okay. So ultimately O2 is 21. That is why excess air supplied is O2 upon 21 minus O2. And we have been given 9% of oxygen in flue gas. This is what is referred. You can ask me all such things which are there, which are substituted. Now, like carbon is 53.65 given to us. So
Yes,
same way, oxygen is 9%. And again, same is to be repeated, 21 minus 9. We'll give you excess air percent 75. Okay. Practically speaking, excess air should be much less than 50% or around 20 to 25%. That is why oxygen percent expected is around 3.5 to 4% in case of coal-fired boilers. Okay. So here excess air supplied is 75%. Now actual mass of air supplied is obviously 75% extra than 7. So 7 into 1, 7.75 is the answer, and it is very simple. So step 3 is quite comparatively easy.
How sir actual mass is supplied?
See, you
1
are
plus
supplied exact amount of theoretical air. You
yes,
are interested in supplying some amount of excess air. That is right.
yes sir.
So ultimately, excess air you have supplied is 75%. So 75% of what? Theoretical air. So theoretical air was 7 kg and excess was supplied was 0.75. So
Oh,
total
oh,
amount of excess air supplied is 1.75 times. So 7
correct.
into 1.75 is this.
Okay, 7.0 into 1.75.
Yes. You need not necessarily write all this formula. You can directly say actual mass of air is equal to 7 into 1 plus 0.75 and you can directly write the answer. There is no hassle in that. Only hassle lies here. You should all remember all these things. That is one unfortunate part from mine. Okay. So now we go to step 4. All the 3 steps are now clear.
Yes sir.
Step 4 we will find out. Again, this is a critical step like step 1. Here mass of dry flue gas has to be found out by mass of CO2 plus mass of N2 in the fuel plus mass of N2 in the combustion air plus mass of oxygen in the flue gas and mass of SO2 in flue gas. So these are all the formulas to be remembered. Particularly for CO2, atomic weight is considered 44. Okay. For nitrogen, they have directly given 0.0111. Then here combustion air supplied is found by 77% nitrogen volume. Then 12.3 is from the problem. Similarly, mass of oxygen is equal to mass of rather nitrogen and actual air. So because it is excess air, so 12.3 minus 7 is taken. Oxygen is as usual 23. Sulfur is as usual 64. SO2 and sulfur is 32. So like that this problem is solved, and it is considering excess air, this mass of dry flue gas is 12.7 kg per kg of coal. You can again refer to the problem.
Sir, mass of CO2 in flue gas. 0.5365 sir, how it has come sir? That is the carbon.
Carbon percent in the flue gas. That is 53.65.
Into 44 by 12. 12 sir, 12 is?
12 is mass of atomic weight of carbon. That is in the numerator they specify CO2, in the denominator they have specified carbon.
Achha, carbon by CO2. Okay.
CO2 by carbon rather.
By carbon. This is 0.0 they have given sir.
They have given, but we will verify. See, this is nitrogen 1.11 divided by 100.
Correct.
Right?
0.01. The percentage is by 100.
Yeah.
So 12.3, sir. 12.3.
12.3 is
Mass of
mass of
into
nitrogen in
mass of
combustion, air supplied.
Actual air supply in yes,
12.3, just now we have found out. Actual air
yes, sir.
supplied.
So actually, totally. Actual mass of
Total air,
into.
and you have to find out nitrogen. So 12.3 into 0.77.
Okay, 12.3 minus 7 will be a put, sir.
That is correct. That is correct. So mass of nitrogen in combustion air is equal to this 12.3 is total amount of
Yeah,
air supplied, and
actual
that
mass.
this
theoretical
7
air. Theoretical air, sir.
theoretical
Yes,
air,
sir. Oh, actual minus theoretical.
right? Into oxygen, you have to find out. That is why you have to find out by 23%. Okay.
Into mass of into, sir. At the mass of oxygen.
In flue gas. Now you can find out. You can specifically collect it from flue gas. Oh, it is not there in flue gas. How they have reached to this 0.0034? Oh, it is
Sulfur,
for
sir.
sulfur.
That is given, sir, sulfur.
This is last. This is last. I was confused. And this is for oxygen. So sulfur, they have mentioned 3.4%. We'll again
64,
verify.
sir. 64. Same thing.
64 is
SO2.
atomic weight of SO2,
Sulfur.
sulfur dioxide.
Okay,
Again, same
SO2.
thing. CO2 at the numerator and carbon at the denominator. Same way, SO2 at the denominator and sulfur at the SO2 at the numerator and sulfur at the denominator. Sulfur has got atomic weight equal to 32.
So this is completely mass of dry flue gas.
So to calculate this mass of dry flue gas, there are three methods all the books are using.
Right.
One is this method, sir. And another one is if they given the H2% and moisture percent, simply AAS plus 1, actual air supplied plus 1 minus 9H2 plus M. That also they are doing.
Yes, that is very good method. Actually, since this is given in the book, I have copied it. But actually, that is really good method. And
moisture also is given here, sir. Moisture. Can we adapt here that one? That
can be very easily adopted. You can refer to the book, and that alternate method can be very comfortably used. And if any problem, we will talk next time. You solve it from the book. I will definitely help, no doubt. Okay?
Okay, sir. This is okay. 12.7 kg per coal. Kg of coal.
Kg per kg of coal. That is actual mass of dry flue gas is 12.7 kg flue gas per kg of coal that is burnt.
Yes.
So now we go to the L1. Okay. So we find first loss L1, which is very, very important for us. That is, again, it is very simple to remember MCP delta T. Okay.
Yes,
as long as paper 2 is concerned, 90% formulas are based on MCP delta T. It is a very good news, I will say. You need not remember many formulas like say paper 3 or whatever. All heat transfer devices in thermal, MCP delta T is very, very important formula. So ultimately, M is 12.7 kg of mass per kg of coal. CP for flue gas specifically is 0.24. If it is CP for steam, when water is coming into picture, it is 0.45. And for all sort of flue gas, CP, all sort of examples, CP for flue gas is 0.24. Right?
That is not given, sir.
CP is not given, but it is well understood, and in exam normally they give it. But even if not given, CP for flue gas is 0.24 and CP for steam is 0.45, right?
Steam is 0.45. Okay.
0.24. Then delta T is this. Flue gas
Yes.
temperature they have mentioned is 180.
Yes, sir.
And atmospheric temperature they have mentioned is 29.3.
Yes, sir. 180 minus 20.
And
That has
receiver
come.
fuel is mentioned. So here
Yes,
this step is very, very easily
Easy.
understood.
Yes, sir.
Right?
Yes.
And here
If
delta T will be common for all the 4 losses, na sir? L1, L2, L3, L4 and
yes,
L4 up
yes,
to L4.
yes, 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 yes.
That is also one trick we can use.
Yes,
One
yes.
advantage.
This is what you perfectly mentioned. Ki once you write all this on paper, na, the things that appear very difficult becomes bit easy. Not
Correct.
fully easy, but bit easy.
Yes, sir.
L2, sir. L2 is heat loss.
L2 is percentage heat loss due to formation of water from hydrogen in fuel. Okay. For that, this formula is there, and hydrogen percent as usual is 3.25, so they have considered 0.0325, and Cp into T2 minus T1 is same like previous, but this is due to moisture water, and Cp has to be taken equal to 0.45, which I just now mentioned, right? If it is related to flue gas, you can take Cp equal to 0.24. If it is related to steam, water, and moisture content, you have to take Cp equal to 0.45. This has to be remembered.
This
In
9,
many
sir.
cases,
9 H2.
yes, what do you want? 9 is as per the formula. Hydrogen is mentioned 3.25%.
That's okay. 9 into 0.23.
And
584, sir.
since
calculate.
hydrogen since hydrogen in fuel is 3.25%, H2 taken is 0.0325.
And okay, sir.
Stoichiometric equation also H2 plus O2, 2H2 plus O2 will give 2H2O, no sir?
Right.
So that also equal H2O will form 9 times of H2O will come.
Yes.
So that is the reference.
Okay. 584, sir. 584.
Latent heat.
584 is latent heat. I already told you that. This is very simple concept, I will say. While reaching to the latent heat at atmospheric pressure, I told latent heat at atmospheric pressure is equal to 540 kilocalorie, and atmospheric condition you have to supply 100 kilocalorie as a sensible part. So latent heat is 540 for atmospheric condition, but the atmospheric temperature of water in this case considered is 44 degree. That is why 584 has come into picture. Okay. So if you are using water at 44 degrees centigrade initially, your sensible enthalpy is 100, sorry, you are considering 56 degrees. So your sensible enthalpy is 100 minus 56, that is equal to 44 degree or 44 kilocalorie. So this 44 has come from that. So 540 plus 44 is considered as a standard, and 584 is taken. Okay.
This is fixed one, sir. This 584 is fixed one.
Fixed one. And in exam, if you don't remember 584, you can comfortably take it as 540 also. Okay.
540 also.
That is also much convenient, no problem. And remember, answers do not vary much by slight variation in the formula.
Okay, so this is heat loss due to formation of water from H2 fuel.
These all words are very important to remember. What we are exactly doing should be understood.
Yes, sir. Heat loss due to yes, heat loss due to water. So then heat loss due to moisture. Okay, so next one, sir, third one.
Everyone is okay with this slide because this is slightly difficult. That is why I am trying to ask. Is it okay? Next slide is quite easy as compared to this. Now L3 equal to percentage heat loss due to moisture in fuel. That is again same thing. M into 584 plus Cp into Tf minus Ta. Here you are again considering moisture. So Cp equal to 0.45. Already we have discussed that Tf minus Ta remains same all over. 584 is a constant. And here hydrogen content, we are considering heat loss due to moisture in fuel. So ultimately this 0.1443 has come from this
Yes.
moisture content in the fuel. Is it clear?
Yes, sir. 2.2% and 3.
Moisture content in the fuel is 14.43%. Okay.
Yes.
So that is why they have taken it as 0.1443 for the moisture in fuel. Exact wording is applicable. They have mentioned moisture in fuel as 14.43 and same loss we are trying to find out. Is it right? So L3 equal to 2.2%. Try to understand that in the exam, if you are able to find out first only L1 and at the most L2, rest of the things can be assumed also. And your answer will not differ much. Okay? Because see, these are the two major losses, 10.7% and 4.4. Rest of the losses are like 1%, 1.5%. So your answer will not deviate much. If you don't even take pains to find out this loss due to moisture in air, loss due to partial conversion of C to CO, that does not matter a lot. Okay? Because it is hardly 0.38, 0.53. You can assume all such losses. And even loss due to radiation can be always assumed as 1 to 1.5%. So this is how you can solve these problems. I insist that you should only remember L1 and L2 and L3, or even L1 is sufficient to remember, and L2 I will say. Okay. Rest of the things, they also know that it is difficult to remember. Everyone is agreed with this. Okay.
We'll have just one time we'll just read it, sir.
You can read. You can
Sure.
read. I have sufficient time. I have no problem. You can ask me all questions. No problem.
Heat loss due to moisture in air. L4, sir.
We will explain that. That is
Yes.
actual air supplied. AS full form is actual air supplied, and it is 7 into 55%. So 7 into 1.55 you have worked out as 12.3. Right? This is already done by us in previous step. I will again show you.
Actual air supplied.
Yeah, this is what we have worked out here. Right?
So 12.3. Okay.
Same thing.
So to find
This
actual amount. So heat
now
loss due to
humidity in
moisture.
air, humidity in air is assumed as 1.9%. Okay.
Humidity in air. They have given
I
it.
think yes.
They have
Humidity.
given, sir. Humidity in ambient air.
What is that given?
501,977.
Kg per kg of dry air. So
Per
same
kg per
thing
kg
is
of
assumed.
dry.
Same thing is assumed or
Okay.
mentioned.
So
CP,
into
CP as far as moisture and water is concerned, it is always 0.45.
0.45. Okay.
So these two figures are to be remembered as far as boiler is
0.3.
concerned.
Okay, so this is 0.3.
Ah.
Next 5 is a heat loss due to partial conversion.
Now percentage CO in air in flue gas.
Percentage CO into carbon, percentage CO.
एक minute. CO is given here. Normally, I will make you comfortable that they do not provide all such values of CO and CO2 in exam. They are trying to understand only L1, L2 and L3 from you. Okay, because these losses are quite negligible. But still, we will try to understand. Percentage CO is mentioned as 0.08 and carbon is as usual 0.5365. Percentage CO is same. Percentage CO2 in the fuel is 11.5. Shall we verify?
Where it is percentage CO2, sir?
We shall verify from the problem.
In fuel, sir. In fuel.
Yes.
Fuel they are not given, sir.
No. Here in
Yeah.
flue gas they have given 10.67%.
11.5 they have not given anywhere, sir. At the CO2 in flue gas, 10.67 they have given.
That is why I am confused. And if we take it
11.5.
10.6, I will say if we take 10.67, it is good enough, no problem. Okay.
But why
We
they
have
have
to
put
verify why
11.5?
they have given 11.5.
Sure.
Now this 5654 has got no any background according to me. We have to again think of this. 5654 is given in formula itself.
5654 they have not given.
No, never, not at all.
They have not given, sir.
Yes.
That is standard one, sir. Standard.
That is standard, but we can't remember all such things. Huh?
So that's 0.5%.
Yeah. That is why I'm trying to tell you that L4, L5 are least worried. We should be least worried about all this.
Okay, sir. 0.5.
So all such losses are added together and they have reached to a figure of 80.7% as efficiency. Now in this case, let us say that you could only find out these three losses. What will happen? 11 plus 5, 16 plus 2, 18. You will get 82% efficiency, which is good enough, isn't it?
Sir.
So I think the concept of indirect efficiency is slightly understood and will be fully understood once you write it on paper. Okay. And actually, you already have suggested to go have a shortcut in step 3 as per the alternate method given in the book. We will, if time permits, we will definitely rather repeat this problem. But let us see how can we go, how can we achieve it. Okay. So now with all this, I have a few more slides to complete in next few minutes. It is not as such this indirect efficiency is not the end of the entire boiler topic. There are few more points added. Actually speaking, boiler is a very vast topic to learn. Many people keep on learning it for years together. So it is not for 10-20 pages can cover the entire boiler. Lot of scientific explanations are included in boiler. So ultimately, coming to the point, the entire performance of boiler depends specifically on water and water quality. So ultimately, the feed water to be supplied to the boiler should have got the best quality. And how can you achieve the best quality of water? There are these three methods. This is water softener, softening of water. This is demineralized water, and this is RO water. RO water is very popular. Whenever we go to public places, we carry this RO water with us, bottle and all that. And that philosophy of that RO water is removal of 90% TDS, particularly helpful for borewell water where the TDS is quite high. Actually, municipal water which we drink after huge filtration process, the RO water is least required, but many people prefer to do it because of many reasons. We'll not go into all details. But application is food and pharma industries and drinking water for human consumption. In many pharma industries and in many food industries, you'll find RO water is being used. And even for boiler also, since instead of going for both RO and DM, many people prefer to go for RO also. But in that case, there is a risk. There are certain minerals added in it. RO water also, many brands or many manufacturers say that it is a mineral water. So necessary minerals of human consumption are added. And if their effect is neglected, then RO water can be used as boiler feed water. But the safest way of using good quality of boiler feed water is demineralized water. This is also called as battery water or something else. Whatever water in automobile batteries used is normally DM water. DM water is all sort of minerals removed. No minerals in the water. RO water you can, as a taste, you can drink very peacefully, comfortably. But DM water, you will find that there is no taste to the water, since all acidic and alkaline minerals are removed by cation and anion. And DM water is preferred for all sort of boilers which are medium and high pressure. And both these rather methods are very, very costly. RO water has got 7-stage membrane filtration. DM water has got many pre-treatment, post-treatment, and so on. And the plant is that way costly, and it has got huge running cost. That cation has to be regenerated using rather caustic soda, and anion has to be regenerated using hydrochloric acid. So ultimately, continuous consumption of acid and alkali takes place at the time of regeneration. So ultimately, initial and running costs are good enough, but water quality is ultimate and the best, because TDS is zero. For engineering and for all sort of water applications, if TDS is zero, it is zero harmful. Okay. But again, regeneration is a specific care required in this. And for low pressure applications, many industries prefer to go for softener, where only alkaline minerals like calcium and magnesium are replaced by sodium salts. Now, if there is a food industry in rural area, they can go for water softener. Rural area I mentioned because the water source is borewell water, and they do not have this filtration plants in a small village like we have in municipal areas. So ultimately, yes, all such borewell waters do contain calcium and magnesium. We find white stains on glass because of calcium content in water. So ultimately, all such harmful alkaline minerals like calcium and magnesium are removed and are replaced by sodium salts, and the regeneration is done using sodium chloride or our regular salt, what you call it as salt for our food. Okay, so sodium chloride. So the application is for low pressure. This is the detail about water treatment, and I would like to specify that water quality has to be continuously monitored in all sort of boilers to have safe running of the boiler and to have rather less maintenance of boiler. But safe running is very important, and for that, water treatment plays very, very important. These are all the recommended feed water quality parameters at different pressures. The most important here is hardness requirement, and as I mentioned, and the pH of all such treated feed water is in the alkaline range. So boiler feed water is always alkaline. That is why again in market alkaline water has entered for human consumption. That is again a marketing strategy. It may or may not be required. That is different part altogether. So this is all, and this iron, copper, and silica content are minimum. We need not be serious about that. So this is all about the feed water quality, and I wanted to introduce you about thermic fluidators, which is as such in parallel to boiler, but water word does not come into picture in thermic fluidators. So ultimately, waterless heating technology is thermic fluidators. So thermic fluidators are that is no water, so no steam, and uh, industrial heating systems where high temperature is offered a great advantage, and establishing this with steam can be troublesome and expensive in many cases. So thermic fluidators are used with the help of uh, synthetic or mineral oil called as thermic oil, and that thermic oil can be heated up to 300 degrees centigrade at atmospheric pressure. In comparison, steam would require for 300 degrees centigrade. If you clearly refer steam tables, this saturation temperature of steam 300 degrees centigrade can be achieved at 85 bar. 85 bar is a very, very risky thing as far as steam boilers are concerned. And if you if pressure is not your process requirement, you can comfortably reach to 300 degrees centigrade using thermic fluid heaters. So there are several advantages in using thermic fluid systems. That is, high temperature operation is possible at atmospheric condition. Optional temperature level set points. There are temperature controllers provided on the panel of thermic fluid heater, and you can have option of setting your temperature levels and actually achieve it. Set temperature, set value and actual value. PV and SV are mentioned on the digital temperature controllers nowadays, which are well known to all of you. No supply of treatment of hot water, and hence no heat loss due to condensate. No question of condensate, no question of feed water and all that. No risk of corrosion. Corrosion only takes place because of presence of water. In rainy season, the rate of corrosion is very high in many cases, in many locations. The reason is water. So ultimately, wherever water comes into picture, there is to some extent a chance of corrosion when it reacts with certain chemical, like say chlorine, sulfur and all that. So there is no risk of that corrosion in thermic fluid heaters, and it is easy to operate. These are the advantages, and this is the just a layout to understand what is thermic fluid heater. This is the expansion tank where the thermic fluid is stored at uh, room temperature conditions, and this thermic fluid is just a makeup thermic fluid. Actually, same thermic fluid is continuously circulated. In boiler, you have to consume lot of water on daily basis based on the TPH capacity. But in thermic fluid heater, the same thermic fluid is continuously recirculated in the system. Whatever loss occurs because of evaporation and many other factors, that is taken care by the expansion tank. And this use of thermic fluid rather is rather expansion tank quantity is that way very rare. Once you fill up this tank, it may be used for 1 year or 2 year like that. So this is just a expansion tank to compensate for losses of thermic fluid. Then this is a deaeration tank to remove the issue of oxidation. And then this entire thermic fluid goes to the pump. Then it is pumped to the system, and here there is a furnace where the thermic fluid being fed is getting heated, and that hot thermic fluid at a temperature of around 350 degree or 300 degree, it's supplied to process at different locations as per your process requirement. And this is a control panel where the digital temperature controllers and all that are installed. And for fuel system, there is a fuel oil filter and all that, and air blower and everything. So ultimately, there are chances of recovering the air also. There are in many cases air preheaters also are installed on thermic fluid heaters, so that high temperature air can be supplied to the process, and the uh, fuel used for heating like say coal, furnace oil and whatever, the consumption gets minimum. Thermic oil is a media, and fuel requirement is necessarily there. So ultimately, you have to run thermic fluid boilers on thermic fluid heaters on by the use of fuels like maybe coal, maybe furnace oil. But furnace oil is getting banned day by day, and you can use even the agro waste and so on to heat this oil. So this is what is the concept of thermic fluid heater, where water conservation can be easily achieved. So this is all with for today, I believe. Okay, you can now ask me all questions you have, and then we'll finish. Yes, for boiler topic.
MCQ, sir, multiple choices.
Okay. Give me 2-3 minutes, please, for comfortable PPT sharing. Okay. Okay, now I think PPT is easy.
Yes, sir. Yes. System in which package type boiler operates with the FD fan. FD fan. Hello. Hello, sir.
Okay, is it clear now? Hello, are you able to hear now?
Yes, sir. Yes, sir. Yes.
Right. Again, I will have to share. There was a disturbance, and again the things have gone. Again, we will have to wait. Or otherwise, okay, that is clear now. It is a balanced draft. I told you that they are using both the things, ID pan and FD pan. So ultimately, the draft generated is balanced. Okay. So,
Only FD fan, sir. First one, a system in which package type boiler operates with FD fan.
Oh, but FD fan is supplied for the
Court system.
for the uh, sufficient amount of air for combustion. Okay, but additionally, ID fan is required in boiler for the sake of discharging flue gas towards the chimney. Okay, so that becomes a necessary part of every boiler, ID fan, because the air and unburnt fuel both as a flue gas should discharge towards the chimney. That is right.
No, the answer is balanced draft, sir.
That is why the answer is balanced draft. Okay.
Okay.
Because forced draft and ID fan, ID induced draft and forced draft, both fans are required. Okay. ID fan is a compulsory part for each boiler. That is why the answer is correct. Okay.
Balanced draft is correct.
Now go to question number 2.
Steam
And
generation boiler is 26 tons into forced consumption. The evaporation ratio. Steam by fuel. I think steam.
So what is the answer?
13, 26 by 2.
Yes, very simple. 13. Economizer in boiler is used to extract it from flue gases for preheating what? This is also very clear to you.
Economizer in a boiler is extract heat from flue gases.
For preheating what?
Feed water.
Very right, yes. Now concentration of solid in boiler drum is controlled by, just now we have discussed on this. Concentration of solids, that is TDS, is controlled
Blow
in a
down.
particular process called as blow down.
Yeah.
Right? So blow down is correct. Hello?
Hello, sir.
Okay? So fourth is clear?
Yes, sir.
We go to fifth. Major heat loss in oil fired boiler is accounted by? That is very clear to you all. We have studied this today.
Tag loss, sir.
Right.
A system in which the boiler
Operates with FD and ID fan is called as again balanced draft. Okay, both the boiler, both the fans are there, so it is balanced draft.
But
Right?
first one is only FD fan, sir. First one.
Okay, but ID fan is a must for every boiler to extract the flue gases, which they have expected us. They are expecting us to know this. That is why FD and ID, both the fans are required. ID fan, if FD fan is not there, then the answer is probably correct. But FD fan is an option. ID fan is a compulsion. Try to understand. Okay. Now this suitable atomizing viscosity of fuel in low atomizing pressure or medium atomizing pressure burners is, this is just a estimation. It is 100 Redwood seconds, but actually this is not a sensible question, I will say. Okay, that is, you need not do it by heart. Next is presence of silica in the boiler water causes. Silica will cause what? Scale formation, right?
Scale.
That is, the silica is a sort of solid. That solid will form scale inside the boiler tubes. Okay? Silica is not acidic. If it is acidic like chlorine, sulfur, then it will form corrosion. Silica is alkaline. Okay? Alkaline will form scale and acidic will form corrosion. This concept is very clear. Removal of dissolved gases from the feed water is called, dissolved gases are to be removed by deaeration. This has to be specifically remembered and understood by you. The deaeration process in all details is explained in the book. Because of many limitations, I did not cover it. Okay. Last, in flue gas, theoretical percent is 15.5 and measured is 11%. The percentage of excess air. This same problem we have solved. Only we had taken 10, here they have taken 11. Sorry. So theoretical air 15.5 divided by 11 minus 1 is into 100 is the required answer.
So 15.5 minus 11 by 11.
Right. No, no,
Actual
no, sorry. Theoretical divided by actual, -1. So
theoretical.
15.5 divided by 11 is 1.4 -1. So 40.9%. Correct? Option A is correct. If you 15.5 divided by 11, if you work out, the answer is 1.49409. Right? Okay.
Okay.
So we will finish for today, I think. Okay.
Yes, sir. Tomorrow, sir. Tomorrow, sir.
Tomorrow I will not be there. On Wednesday we have one more lecture. Okay.
अच्छा ma'am.
Thank you.
Okay, perfect.
सर पहिलं लेक्चर 2 ला सुरू झालं का? हॅलो
सर 3:15 को स्टार्ट हो गया सर आज का लेक्चर.
नहीं, लेकिन ग्रुप में 4:15 डाला था ना गंदे सर ने.
पता नहीं, मैं भी ज्वाइन हो गया था तब टाइम सब लोग था, चालू हो गया था.
हाँ, यस.
Maybe we will get the recording session, sir. Don't worry.
Yes. Okay.
So we will. Today, Pramod sir has conducted the fuel and combustion and the boiler.
Okay.
Boil.
Yeah. Okay. Thank you. Thanks.
Thank you, sir. ఎல்லாம் సుమా చిన్ని కావ్య వస్తావా కిందకి?
అదంటే బయటికి వెళ్దాం ఉంటుంది తీసుకెళ్ళి
బయటకి లేదు, కిందకి.
కిందకి కాదు. వాళ్ళ అమ్మ తను ఎవడో వస్తారంట, తోడు వెళ్ళరండి అక్కడ పార్క్ కంట. పోయిరకు
వాళ్ళ తోడు ఇక్కడ ఆడుతున్నా రామ కింద
తీసుకెళ్తారా?
ఐక్యనా పండుకుంటా?
అదే అదే అది కొరాలి.
అది మాకు అక్కర్లేదమ్మా, నువ్వు కొనుక్కో.
అదేంది కావాలి చూడండి అక్కడ. అవునండి, ఇప్పుడు డబ్బులు వేయించుకుంటున్నారు కదా, అవి నగ్గించి ఇవ్వటానిక లేకపోతే బంగారం తేటానిక? రెండు నెలకి 50 వేయించుకుంటున్నారు కదా. వేసాడు కదండి, యాడ్ చేసుకుంటున్నారు. నాకు అర్థం కాదు.
వాళ్ళకి సరిపోతుంది.
చెప్పు.
లేదు లేవు ఇంకా.
గోల్డ్ కావాలి.
ఏమో తెలియదు లెక్క. జీతాలు వేస్తుంటాం, పిల్లలు పెరిగారు కదా అసలు. ఇప్పుడు అది నువ్వు చెప్పింది కరెక్ట్, 100% కరెక్ట్.
ఈ అబ్బాయి ఏమయ్యాడండి హాస్పిటల్?
ఏదో చూస్తున్నాను, ఏదో డీల్ మాట్లాడుతుందంటే ఫైనాన్షియల్స్ మాట్లాడగానే మీకు చేస్తానన్నట్టు. చూద్దాం, ఏం చేద్దాం, వెయిట్ చేయాలంతే. అమ్మాయి ఏం చేస్తుంది?
భూమి కొట్టండి ఒకసారి. నాకు ఎడంగా
ఏమైంది? మంచిదే కాదు, డబ్బులు వస్తాయి అంతే కదా. వెనకాల అయితే మంచిది ఆడవాళ్ళకి.
కుడికన్ను మగోడికా తెలుసానికి? నాకు తెలియదు. గోగుల్ కూడా చూడు, జాతకాలు వాటిలో చెప్తారు. మధ్యాహ్నం నుంచి అదురుతుంది. లక్ష్మీదేవి పొద్దున్న తీసేస్తుంది, దేవుని తీస్తుంటే డబ్బులు ఇవ్వలేదు నాయనమ్మ ఆవిడ. తీయద్దు నువ్వు దేవుణ్ణి, డబ్బులు రాలేదు మనకి ఇంకా. అమ్మవారి డబ్బులు ఇస్తుందని చెప్పావు కదా.
తెలుసు,
పూజ చేసుకుంటే డబ్బులు వస్తాయి అమ్మా, దేవుడికి దండం పెట్టుకోవాలి అది ఇది అని అంటాను కదా నేను. డబ్బులు ఇవ్వలేదు, డబ్బులు ఇవ్వలేదు నాయనమ్మా. నువ్వు తీయమాకు నాయనమ్మా, డబ్బులు ఇవ్వాలి కదా. అమ్మాయి పొద్దున్న దేవుని తీస్తుంటే నాయనమ్మ డబ్బులు ఇవ్వలేదు నాయనమ్మ దేవుడు మనకి, నువ్వు డబ్బులు తీయద్దు దేవుణ్ణి, అమ్మ ఫోన్లో డబ్బులు పడలేదు, మనకి డబ్బులు రాలేదు నాయనమ్మ, నువ్వు అమ్మవారిని తీయద్దు నాయనమ్మ, డబ్బులు ఇయ్యలేదు అమ్మమ్మ. అమ్మవారు డబ్బులు ఇచ్చే వరకు ఉంచు నాయనమ్మ ఇక్కడే. పొద్దునండి డబ్బులు ఇవ్వలేదు కదా అమ్మవారు, అదిగో నేను చెప్పాను అమ్మాయి పూజ చేసుకుంటే ఎందుకు నాయనమ్మా ఇది చేస్తున్నావు అంది. లక్ష్మీదేవి పూజ చేసుకుంటే దేవుడు మనకి డబ్బులు ఇస్తాడమ్మా, డబ్బులు వస్తాయి అన్న. అమ్మకి నాన్నకి మనందరికి డబ్బులు ఉంటాయి అమ్మా.
డబ్బులు వచ్చాయా?
రాలేదంటే
నీకు రాలేదా? ఎందుకు?
పెద్దదాన్న వాళ్ళ డబ్బులు రాలా. నువ్వు తీయకు నాయనమ్మా, మనకి డబ్బులు ఇవ్వలేదు ఈవిడ, నువ్వు ఉంచు నాయనమ్మా డబ్బులు ఇచ్చే వరకు.
Consider good woman for women. Consider good or inauspicious for men. Twitching of the left eye. Twitching is positive during the day, negative at night. నీకు పగలేస్తే మంచిదంట. These are not scientific కాదు, but are widely circulated in folk beliefs. Medically, eye yield twitching caused by fatigue, stress and anxiety.
అలా కాదండి,
మనకి
మనకి మంచిగా చెడు అనేది చెప్పేది
మంచి
మంచిగా అంతేగాని
ఒక వారం అంటే ట్విచ్చింగ్ ఉన్నట్టు.
నాకు వారం లేదు పొద్దున్న నుంచి. మంచి జరిగేట ఎడం కన్ను కూర్చుంటాను
మంచిది.
తీసుకెళ్తారు మా అమ్మ చెబుతుంది ఆ పని అమ్మాయి ఇట్లా అంటున్నాడమ్మా వంట బాగోలేదంటే పోగొట్టుకోమాకమ్మా, నువ్వు చేయలేవు అయిపోయింది ఉన్న మనిషిని చేసి కట్టుకుంటుంది చూడు నా కన్ను చూస్తుంది దగ్గర. ఇదిగో చూడు మళ్ళీ అయిపోయింది మళ్ళీ.
సినికా
బొమ్మనైతే వేయలేదు.
ఎక్కడికి?
తిరుపతి.
తీసుకెళ్తాను.
వాళ్ళు ఇంకా సర్దుకోండి పాపం
చదువుకొని
ఇంట్లో బాగుంటుంది. ఇంకా క్యాలిక్యులేటర్ అక్కడ ఉందిగా
ఆఫీస్ లో ఒకటి పెట్టాను. మన పోయిన తర్వాత చదువుకుంది.
అది పని చేయడం అక్కడిది అక్కడ హలో సర్దుకున్నావా అమ్మా? సర్దుకోవటం బట్టలు శాల్వాలు పెట్టుకున్నావా? శాల్వాలు 2 పెట్టుకో. శాల్వాలు 2, తర్వాత క్రోసిన్లు, మోషన్ టాబ్లెట్లు. అయినా కానీ సరే ఇట్లా ఉంచుకో, మా వర్షాలు పడుతున్నాయే. నువ్వు పోయే కార్డులో నేను ఏమైనా మోస్తున్నావామా? నాది అవ్వలేదు, అన్ని తోమప్పుడు ఉన్నాయి. కానీ నువ్వు ఏం చేస్తావంటే శాల్వాలు పెట్టుకో 2, తర్వాత ఏమో క్రోసిన్, మోషన్ టాబ్లెట్లు పెట్టావా? ఆ బాక్స్ పట్టుకెళ్ళిపో. నొప్పుల టాబ్లెట్లు కూడా పెట్టుకో, అన్ని అయ్యే పట్టుకెళ్ళిపో. మొత్తం బట్టలు జ్వరం వచ్చి మొత్తం అన్ని ఎట్రజాన్ టాబ్లెట్లు, ఓన్లే ఎట్రజాన్ టాబ్లెట్లు అన్ని. ఎన్నింటికి రేపు బయలుదేరేది? ఎన్నింటికమ్మా? సాయంత్రం ఎన్నింటికి? ఎందుకే సాయంకాలం 6కి బయలుదేరి 12కి వెళ్ళిపోక నువ్వు టీవీ మయంలో ఉన్నావు. చూస్తున్నావా సీరియలా? ఏ సినిమా ఎందులో వస్తుంది? ఏమండి ఈటీవీ అని పెట్టు, ఆది పరాశక్తి వస్తుంది. సీరియలా పెట్టి
బయటకు వెళ్తున్నావా? బయటకు ఏం చేస్తామ్మా? ఇది బేబీ షాప్ వద్దా?
అమ్మా ఏం చేస్తున్నావు? మీరా దా మీరా దా దా ఏం చేస్తున్నావు? పలకరించా లేదు వెళ్తుంది బయటికి. ఈటీవీలో ఇది వస్తుంది కదా ఏడా సీరియల్ గా రంగులు రాట్నం అంటే అది కాదు. ఈటీవీ 9 లైఫ్ అంట పెట్టు. ఈటీవీ లైఫ్ అంట. బెల్ల ముక్క తీసుకుంది రాసి ఈటీవీ లైఫా? అమ్మ ఈటీవీ లైఫ్ చూడు ఏదో మా అమ్మది ఇస్తుంది. 83 అంటే నీకు అది లేదు మాది. టాటా స్కై మాది. టాటా స్కై మాది. అమ్మవారి ఏదో వస్తుంది. ఆది పరాశక్తి ఆది పరాశక్తి లైఫ్ ఈటీవీ లైఫ్ లైఫ్ ఆయన కొన్నిటికే తీసుకుంటారు.
నాలుగు వచ్చాను
ఈటీవీ లైఫ్ అని చెప్పండి. అదే
ఏనా
అమ్మా ఇప్పుడు మాట్లాడుతుంది ఆవిడ తెల్ల బట్టలు వేసుకొని ఆవిడేనా తెల్ల బట్టలు వేసుకుంది ఇంటి వాళ్ళది కదమ్మా ఇది హిందీ హిందీ డబ్బింగ్ తెలుగు ఎప్పుడు శివుని చూడనంటుంది శివుని ఎప్పుడు చూడను అంటుంది అవునా ఎన్నో ఛానల్ అండి అది ఎక్కర్లేదు ఎన్నో ఎన్నో నెంబర్ 145 145 145 1 స్టార్ట్ అవును 145 అదే అంటాను దక్ష ప్రజాపతి సరే అయితే చూడవే ఖాళీ అయితే తర్వాత నువ్వేంటి సరే సౌండ్ పెట్టండి నేను ఇక్కడికి ఎందుకు వచ్చాను కేవలం ఇంట్లోనే కాదు పుత్రిక సదీక్ ఇక్కడ ఉండాలి ఈ మహల్లో ఆ మనుషులు తల్లిని మహల్ నుంచి వెళ్ళట్లేదు కాబట్టి మీకే అనిపిస్తుంది వాళ్ళు మళ్ళీ తల్లిని ఇక్కడికి తీసుకురాగలుగుతారు ఈ ఒక్క పనిని మాత్రం నన్ను చేయబడి నాన్నగారు కూతురున్నారు దానికి మాత్రం దిగి నిన్ను ఆవాహన చేసుకుంటాను నా తండ్రి ఆదేశాన్ని అవహేళన చేసింది అతనికి. ప్రజాపతి దక్షిణ్ణి అవమానించింది. అది ఎక్కడన్నా సరే వెంటనే ఇక్కడికి తీసుకురా. ఇంకొక విషయం, నిన్ను కనుక ఎవరైనా ఆపితే వాళ్ళని నాశనం చెయ్యి.
నా ఉద్దేశం ఇక్కడికి ఎందుకు వచ్చాను ఇది కూడా అర్థం చేసుకున్నాను. ఏ దృష్టితో నువ్వు నా దృశ్యాన్ని చూస్తున్నాను, ఇది ఆ దృష్టికి భిన్నం. దీనిని నేను చూసినప్పటికంటే ఇప్పుడు మీ దృష్టిలో ఇది పాపాన్ని అంతం చేసి లోకంలో సంతులతని స్థాపించే సాధనంగా మాత్రమే లేదు. ఎందుకంటే ఇప్పుడు దీనిపై నీకు ఆ బ్రహ్మదేవుడి రక్తపు మరకలు కనిపిస్తుంది.
నేను కేవలం నిజం తెలుసుకున్నాను. ఎందుకు మీ దృశ్యంలో బ్రహ్మదేవి హత్య చేస్తూ కనిపించారు.
నా ఈ ఆశ చూస్తాను. దీనిపై నేను కూర్చున్న ఎవరు నాకు ఏ అవకాశం కలిగించారు. కానీ ఒక సమయంలో బ్రహ్మదేవుడికి ఇలాంటి తుచ్చమైన విషయాలు చాలా పెద్ద అంతరం వచ్చేది.
ఏమండి?
భౌతిక
నెంబర్ ఏంటండి?
5-1.
మీ భావన ఏంటి?
ఈ సంపూర్ణ సృష్టి రచన నేనే చేశాను. మహాదేవ విష్ణుల రచన కూడా నేనే చేశాను. మరి వారిద్దరి ఆచరణను నాతో సమానంగా ఎలా చేస్తావు? నువ్వు నా సామర్థ్యాన్ని ప్రశ్నార్థకం చేశావు. ఇప్పుడు నేను చూపిస్తాను అమ్మ ఏం చేయగలరు. ఈ అలంకారం కారణంగా సృష్టి తంతులత చెడిపోతుంది. ఎప్పుడైతే ఏదైనా లేక దుష్కరణ నాటి సృష్టిని సమస్యల్లో పడేస్తుందో అప్పుడు నేను శివుణ్ణి నా సంహారక అవతారాన్ని దారుస్తాను. నేను బ్రహ్మదేవుడి 5 శిరస్సుని కేవలం ఎందుకు ఖండించానంటే దానికి ఆధారం అహంకారం కాదు. ఆ అహంకారం ఆయన వివేకాన్ని హరించి వేసింది. తన 5 శిరస్సును ఖండించగానే బ్రహ్మదేవుడికి ఆ అహంకారం అనే వికారం నుంచి ముక్తి లభించింది. ఈ లోక రచయిత అహంకారి అయితే అది ఈ లోకానికి అత్యంత ఘాతకంగా తయారు. అందుకే ఈ లోక హితం కోసం నేను బ్రహ్మదేవుడు ఈ పాపం నుంచి ముక్తిని చేయడం. కైలాసానికి ఎవరైతే మంచి మనసుతో వస్తారో వాళ్ళెప్పుడు కాలి చేతులతో తిరిగి నువ్వు కూడా ఏ ప్రశ్నకి వెతుకుతూ ఇక్కడికి వచ్చాకు దాని జవాబు నీకు తెలిసిపోయింది. ఇక వెళ్ళి నారాయణ నారాయణ ఏముందని తల్లి ఎక్కడ చూసినా స్వర్గసీమ చంద్రశేఖర్ అంతే కదా. స్వర్గసీమ బెంచ్లో పెట్టుకోవాలంతా సుఖంగా ఉన్నాడు. స్వర్గసీమ బెంచ్లు తరాలంతా వెలిగించున్నాయి. ఇక్కడ పెట్టుకోవాలంతా ఆపించారు. మీరు కూడా ఆస్వాదిస్తున్నాను. అన్లిమిటెడ్ బెనిఫిట్స్ ఎక్కడ ఇచ్చేది.
కావేరీ నదీ తీరం మహర్షులు దర్శించిన తపోస్థలం. త్రేతాయుగం నాటి రామేశ్వర లింగం. కర్ణాటక రామనాథపురంలోని రామేశ్వర ఆలయం ఈ వారం దివ్య క్షేత్రంలో రేపు మధ్యాహ్నం 12 గంటలకు తిరిగి శనివారాల్లో మధ్యాహ్నం 12 గంటలకు
మళ్ళా దగ్గర వస్తే దృశ్యాల నుంచి గురు పరంపరతో విధించిన జ్ఞాన నిజం ఆధ్యాత్మిక జీవనానికి విజయ సోపానం. బ్రహ్మశ్రీ గజపతి రామకృష్ణమూర్తి ప్రవచనామృత గురు సందేశం. ప్రతి ఆదివారం సాయంత్రం 6 గంటలకు, ప్రతి గురువారం మధ్యాహ్నం 12 గంటలకు మీ ఆధ్యాత్మిక ఛానల్లో.
సింహరాశి వారికి అన్ని పనులు విజయవంతంగా ఉంటాయి. ఏమైనా పని ఒకటి రాశి వారికి కళారంగంలో ఉన్నటువంటి సాధన మాత్రం అప్రయత్న సాధించేస్తుంది.
మీ ఈటీవీ ఆధ్యాత్మిక ఛానల్ రేపునే 7:30 నిమిషాలు, తిరిగి రాత్రి 8 గంటలు, సోమవారం మధ్యాహ్నం 10 గంటలు. విజ్ఞానులు తొలగించే విఘ్నేశ్వరుడు జ్ఞానం, విజయం, సంస్కృతులకు అధిపతి. స్నానం చేయాలి, దేవుడు అయ్యాము.
తినడానికి ఏముంది
బోర్డు
ఇది తెలియదు ఒకసారి
కిందకి దోశ ప్యాకెట్.
దోశ
హలో
ఎందుకు నాకు ఇది
మళ్ళీ పాప
ఉపకరించే వేద విజ్ఞానం
కొంచెం చూపిస్తే ఏం లేదండి. కొంచెం పంపిణీ పడిపోతుంది. మనంగా మోసం చేయకూడదు.
ఏ ప్రశ్నకి జవాబు వెతుకు ఇక్కడికి వచ్చినప్పుడు దాని జవాబు నీకు తెలిసిపోతుంది.
చూపిస్తుంది డ్రెస్ వేసుకున్నాను, కోరుకోవాలి. డ్రెస్ వేసుకుంటా మంచి డ్రెస్ ఎప్పుడు తిరిగి లైటింగ్ వస్తుంది. అంటే ఒక ట్రీట్మెంట్ గా తీసుకుంటాను. నేను చేసి ఎక్కడైనా హాస్పిటల్లో అంటే అది ఒకటి చెప్పాను. నేను నా పనులు పైకి నేర్చుకుంటాను. ఇక వెళ్ళిపోయిన దక్షపుత్రిక పతి అన్ని నమ్మి మీ మళ్ళీ తన బరిగా నేర్చుకుంటే మనకు అవసరమైన వాళ్ళకి చెప్పడం అవుతుంది.
నేను
వెళ్తారా తను
మీ వాహనాన్ని గౌరవిస్తాను.
మన బిడ్డనే ఉంటాడా?
నేను సత్యాన్ని కూడా ఊరేలా చేస్తాను. శివుడి జీవితంలో
ఎంత తీసుకుంటుందండి?
ఆ స్త్రీ
సరే ఆమెలే నా శిలువ ఇప్పుడు ఉండదు. ఎప్పటికీ అసలు శివుడి శక్తి నా దేవుడు.
తెలియదు వాళ్ళకి కాదు మనకి ఇంకా అర్థమైపోయింది అనుకో తెలిసి నాకు తెలిసింది అర్థమేమి చెప్పి అనుభవం ఒకసారి చెప్పింది వాళ్ళు ఏంటంటే
ఏది వరకు నీకు తెలియదు.
ఆధ్యాత్మిక జీవనానికి ఇది సోపానం మధ్యాహ్నం పన్నెండు గంటలకు లేదు, ఇలా జరగడానికి లేదు.
క్షమించండి మాత, కానీ దేవతలు బ్రహ్మలోకంతో పాటుగా స్వర్గలోకం కూడా మా నుంచి లాక్కున్నారు. ఆ దేవరాజు ఇంద్రుడు దీన్ని మీకోసం పంపాడు. దేవరాజు ఇంద్రుడు చెప్పాడు, మీరు ఈ ఇంద్రాసనాన్ని పాతాళ లోకంలో ఉంచుకోవచ్చట. ఎందుకంటే మీతో చెప్పమన్నారు, దేవతలకి యుద్ధం ఓడిపోయిన ఇంద్రాసనాన్ని మళ్ళీ సంపాదించడానికి కాదట. యుద్ధానికి వాళ్ళకి ఇది ధర్మ యుద్ధం అట. పాతాళం స్వర్గలోకాల నిర్మాణ సమయంలో దేవి వీళ్ళిద్దరి నిర్మాణం కోసం ఏ హద్దులు నిర్ణయించిందో దాన్ని మళ్ళీ స్థాపించడానికేనట.
తన ఇష్టానికి విరుద్ధంగా ఎవ్వరు పాతాళ లోకానికి తీసుకువెళ్ళలేరు. స్వయంగా దైత్యం మాత దితి కూడా. నేను కేవలం శివుడి దగ్గరికి ఎందుకు వెళ్ళానంటే నా ప్రశ్నకి జవాబు తెలుసుకోవడానికి. ఆయన పరమపిత బ్రహ్మదేవుని 5వ శిరస్సుని ఎందుకు ఖండించారా అని.
చూస్తే దగ్గర దగ్గర 11,000 కిలోమీటర్లు, 11,000 కోట్లు, 700
ఆధారాలు దొరకాలి. తిరుపతి ఆందోళన నియామకాలపై అభ్యంతరం, అంతర్ జిల్లాల బదిలీలు చేపట్టారంటూ డిమాండ్. మంత్రి పదవి వద్దని నేను అధిష్టానానికి చెప్పలేదు. ఏ బాధ్యత ఇచ్చినారని వ్యాఖ్యలు. రైతులకు ఎరువుల పత్రాలు, మీటర్, ఇందిరమ్మ రాజ్యం అంటే ఇదేనా? కాంగ్రెస్ సర్కార్పై మట్టి పడ్డ ఢిల్లీ. జేడీఎస్ మాజీ ఎంపీ ప్రెసిడెంట్ రేవణ్ణకు జీవిత ఖైదు, జైలు శిక్షతో పాటు 10 లక్షల జరిమానా, బాధితురాలికి 7 లక్షలు చెల్లించాలన్న కోర్టు. ఇద్దరు కేరళ మత మార్పిడులకు పాల్పడుతున్నారని ఆరోపణలు. వారిలో 3వ అతిపెద్ద ఆర్థిక వ్యవస్థగా భారత్. రైతులు పరిశ్రమలు ఎలాంటి విషయాలు వెలిగిస్తాయో తెలుసా? ఇవి తింటే వెంటనే ఫుడ్ పాయిజన్ జరగడమే కాదు, దీర్ఘకాలం ఆరోగ్యట్లయితే
ఇంట్లో ఫుడ్ లేదని బయటకు వెళ్తే అక్కడ తిండి మహాఘోరంగా ఉంటుంది. సరిగ్గా ఉడికి ఉడకని కూరలు, రుచి పచ్చి లేని భోజనాలు, రంగులద్దిన మాంస పదార్థాలు, ఎసెన్స్లు వాడిన బిర్యానీలు, కల్తీ పాలు, నెయ్యి, టీ పౌడర్లు, ఇక మసాలాల గురించి అయితే చెప్పనక్కర్లేదు. ఏది తిందామన్నా అందులో ఏం కలిపారు అన్న డౌట్, ఏం కొందామన్నా సరైన ఫుడ్ ఇస్తాడో లేదో అనే అనుమానం. ఇంటికి డెలివరీ అయ్యే తిండి ఎప్పుడు వండారో కూడా తెలియదు. హైదరాబాద్ లో వచ్చిన ఈ కాలంలో ఏ ఫుడ్ సరైనదనే నమ్మకం లేదు. 2 రోజుల నుంచి హోటల్స్, ఫుడ్ అవుట్లెట్స్ పై రైడ్స్ నిర్వహిస్తున్నారు అధికారులు. ఇది చాలా చోట్ల హైజీన్ కనిపించలేదు. అపరిశుభ్ర వాతావరణంలోనే వంట వార్పు చేస్తున్నారు హోటల్ నిర్వాహకులు. ఈ హోటల్స్, రెస్టారెంట్ లో నీట్నెస్ మెయింటైన్ చేయడం లేదు. అంతేకాదు పాత్రలు, ప్లేట్లు శుభ్రం చేసే దగ్గర కూడా అపరిశుభ్రత. దీనివల్ల కస్టమర్లకు ఫుడ్ పాయిజన్ జరిగి డయేరియా, వాంతులు, టైఫాయిడ్ వంటి రోగాలు వస్తాయి. మరోవైపు రిఫైన్ ఆయిల్ నే వాడతామని డబ్బాల కొట్టుకునే రెస్టారెంట్లు వాడిన వంట నూనె వాడుతూ ఆహారాన్ని కలుషితం చేస్తున్నారు. దీనివల్ల క్యాన్సర్ వంటి రోగాలు వస్తాయి. అధికారుల తనిఖీల్లో నిల్వ ఉంచిన నాన్ వెజ్, పాచిపోయిన అల్లం వెల్లుల్లి పేస్ట్, పాడైపోయిన గుడ్లు, వాటితో పాటు కారం చెల్లిన ఆహార పదార్థాలను గుర్తించారు. నిన్న 40 చోట్ల రైడ్స్ చేసి 42 శాంపిల్స్ సేకరించారు. 17 కేసులు నమోదు చేశారు అధికారులు. పరిశుభ్రత పాటించని 10 రెస్టారెంట్లకు ఇంప్రూవ్మెంట్ నోటీసులు ఇచ్చారు. మొత్తం 20 బృందాలు మిరపదాడులు నిర్వహించినట్టుగా అధికారులు తెలిపారు. ప్రజల ఆరోగ్యంతో చెలగాటమాడేది ఉపేక్షించేది లేదన్నారు జాయింట్ ఫుడ్ కంట్రోలర్ పూర్ణచంద్రరావు. సగం ఉడికిన నాన్ వెజ్ ని నిల్వ ఉంచి మళ్లీ వండి వడ్డిస్తున్నట్టుగా గుర్తించామన్నారు. హానికారక ఫుడ్ కలర్స్, టేస్టింగ్ సాల్ట్ వంటివి ఉపయోగిస్తున్నారని, అటువంటి ఆహారాన్ని తింటే అల్సర్, క్యాన్సర్ వచ్చే ప్రమాదం ఉందన్నారు. కలర్స్ ఎక్స్పైరీ కలర్స్. కలర్ ఉంది జనవరి 22 మ్యానుఫ్యాక్చర్ 2 ఇయర్స్ 24 జనవరికి ఎక్స్పైర్ అయిపోయింది. ఎక్స్పైర్ అయిపోయి కూడా 1.5 year అయింది. ఇదే కలర్స్ వాడుతా ఉన్నారు. దీని తర్వాత సోయా సాస్ ఉంది. సోయా సాస్ ఎక్స్పైర్ అయిపోయి కూడా 6 నెలలు అయిపోయింది. ఇవే వాడుతున్నారు. సాసులు కానీ, ఫ్లేవర్స్ కానీ, కలర్స్ కానీ ఎక్సెస్ వాడుతున్నారు, నాన్ పర్మిటెడ్ వాడుతున్నారు, ఎక్స్పైరీ వాడుతున్నారు. ఇది ఎక్స్పైర్ చేయలేదు మేము. ఎక్స్పైరీ కలర్స్ కానీ, ఎక్స్పైరీ ఫ్లేవర్స్ వాడతారని ఎక్స్పైర్ చేయలేదంట. ఇంకా 10 బాటిల్స్ ఎక్స్పైరీ కలర్స్ ఉన్నాయి, ఎక్స్పైరీ ఫ్లేవర్స్ ఉన్నాయి. వీళ్ళందరూ చట్టపరమైన చర్య తీసుకుంటాం. ఎక్స్పైరీ ఎక్సెస్ కలర్స్ వాడితేనే, నాన్ పర్మిటెడ్ కలర్స్ కానీ, ఎక్సెస్ కలర్స్ వాడితేనే లివర్ డ్యామేజ్, కిడ్నీ డ్యామేజ్, మెయిన్ ఆర్గాన్స్ చచ్చిపోతాయి. మరోవైపు బేకరీలు, డ్రై ఫ్రూట్ షాపుల పైన దాడులు నిర్వహించారు అధికారులు. పాడైపోయిన పురుగులు పట్టిన డ్రై ఫ్రూట్లనే స్వీట్లు, బేకరీ షాపులకు సరఫరా చేస్తున్నట్టుగా గుర్తించారు. ఓ స్వీట్ షాప్ లో పురుగులు పట్టే పరిస్థితుల్లో డ్రై ఫ్రూట్స్ ఉన్నాయని అన్నారు ఫుడ్ సేఫ్టీ అధికారి శ్రీజ. అక్కడి నుంచి బాదాం, పిస్తా పప్పును స్వీట్ చేసి శాంపిల్స్ ను ల్యాబ్